Hola. I cannot remember the decision, but can they announce what happens?
Sí. Sí.
I'm going to send the students in, guys.
Yeah, I'm working.
Good morning, everybody. Welcome. Sorry for the delay, but we had a 50-minute delay, but very fine to be here. I'm happy to see your faces, see that all you're very fresh and keen to start learning. Just a few words before starting the lectures. We have the toilets close by, so you guys can, they're right next to the reception where that beautiful painting is. You can go there else. As you have seen, every day we will have lectures in the morning, coffee break, then more lectures, then a break, then more lectures, then a coffee break, and then more lectures. So this is the structure of the school. relay. It will be very extensive, but yeah, without further ado, I will open the session and transfer the words to Mr. Tiziano, Dr. Tiziano. So, welcome and have a beautiful school.
No, wait. Can you hear me without the microphone? Yes. Can we go without the microphone?
Yeah.
Thank you. So, Mike, why is no one sitting in the front? No, it feels bad. It feels like you're okay. Okay, no, well, in the reminder of the week, I hope that you will find, that you can allow yourself to sit in the front. Are we complete? Yes, are we? I was expecting. So maybe we are not complete. You should sit in pairs. You are going to work in pairs the whole week. The lectures are prepared by us. If something doesn't work, there are people in the back, right? That person.
We already got on some problems.
Exactly. So there may be some little problems there. They will be fixed in the background. But anyway, if you notice something doesn't work as you expect, the two guys with the green shirts are responsible for the setting up. Well, almost green. I mean that color. Salsa verde color. Yes, we are going to speak English because most of the faculty doesn't speak Spanish. So among you, of course, you can speak Spanish, but it would be nice if we try to interact in English. Anyway, if you are serious about doing programming, not being a programmer, even just as a scientist, you need to do this kind of things we're going to do. Everything is in English. So it doesn't make much sense to Google Spanish things when it's about Git or NumPy or the other things we're going to do. So, because yesterday night I had the impression that some people are a bit scared that they are not good enough. So this school is explicitly not for programmers. None of the people in the faculty have been trained as programmers. So we are scientists, or we were scientists, like you. And the goal of the school is not to make you a programmer. So actually, if you don't like to program, this is the right school for you. So because the goal is to make you program as few as possible, spend less time programming as possible. So in the end, to do that, we try to make the code more efficient, so that you don't have to spend hours and hours programming. Okay? So don't worry if you don't feel you are a programmer, this is the right place for you. I hope you have gone through the introductory material, especially for those that said that they are not experienced in Python and experienced in Git, because I'm going to assume that you know what I'm talking about when I say Git, when I say commit, when I say these kind of things. And if you cannot follow, you have to interrupt. So the idea is that all the lectures are structured in a way where most of the time is spent doing exercises. So I'm not going to talk for hours. No one is going to talk for hours in front of you. So you have to be active. And when you don't understand, you ask. If me or anyone else in the faculty says words you don't know what they are, you ask. If you don't understand our English, you ask, and so on. So really, let's make that as interactive as possible, because I personally hate speaking in front of faces like this, and that show no reaction. So you show reactions, you laugh, you whistle, you do whatever. Let's be active. So I said, the goal is to spend less time writing code. And as a side effect, you will get code which is more usable, is more reusable, and is easier to understand. So all of these are side effects of the fact that you spend less time writing code. So another good thing, another side effect is that what we hope to achieve is that your code is going to be more correct, right? So in the reminder of the school, you will learn how to write tests for the code. So that, because if you are scientists, the difference between us and programmers outside, in the outside world, is that scientific programming has the challenge that bugs are not allowed. Like if you are working in the industry and the product you produce has a bug, the bug can be fixed, is annoying, but it's not really invalidating whatever the product you are producing. In our case, because most of the time, your science is the numbers you get out of a computer program. If that program has a bug, then your science is not valid anymore. So we have a completely different focus than the one that the industry has. And that's why this program started in Europe now almost 14 years ago, because we realized that everything is available in the internet. You will see that you are not going to see any of our material is particularly unique. Everything you will see is available on the internet in 100 different versions. The problem is that most of the stuff you find on the internet is tailored to programmers in the business. So they care about other things. They care, for example, that programs can be edited in huge groups, that can be distributed, and all these things. And we care about the fact that the code is correct, that people in my group can reuse the code I've done, that me, myself, I can reuse 2 years later the code I have written, that we have as few bugs as possible, because there is no code without bugs. But we care a lot about correctness of the code. So, another thing is that if we leave you alone, so typically when you learn in science, and you may have, if you're lucky, 1 semester or maybe 1 year programming course. Most of scientists don't have any introduction to programming. You start programming on your own. And so you use Google at the beginning. And then when you start learning that Google most of the time gives you Stack Overflow replies, you start using Stack Overflow. Now, the problem with Stack Overflow, and by the way, with ChatGPT now that there are advanced things, is that if you don't know how to verify that the stuff that's there is correct, then you're a bit left on your own. And I've seen, I'm teaching since many years, I've seen really crazy Stack Overflow horrors distributed. So people, they just copy whatever they found in Stack Overflow to solve a problem, then you stick it in, you have no idea what the thing is doing. And I have a nice example. I want to see if you, so I think I can write here, but that's too small. That's not going to. I write in the terminal so that you see. So font, bigger font. Now, first test of interaction. Can you read it? Especially the people in the back. Yes? Bigger? Bigger? Oh, what is this? Is it okay?
Yeah.
Yes?
There's also monitors on the side.
Yes, for those in the back, there is this monitors on the side where the screen is projected or something.
It's just that in particular, the cable is very twitchy, so you touch it and it stops.
So, oh no, we'll do it with the Python prompt. So if I define a string, this is a string ABC with some white spaces in the middle, and I found in this string code this line. So, my reaction was, what the fuck? What is this thing doing? Do you have any idea? Someone says yes. Don't say the answer. Wait. No, don't say it. Don't say it. Wait a second. I want to see if anyone else out of 30 participants has an idea what this code is doing. 2, 3, 4, 5, 6. Oh, okay, 6. So let's say that we are more or less at 1/3, well, a bit less than 1/3 of the participants have an idea what this is doing. So this is for me already a sign that the code is bad. Okay, so you all know Python. So my assumption is that every line of code I write should be almost immediately clear what it's doing. Now, if 2/3 of the participants have no idea what the code is doing, it's already a problem. Now, you were the first one with a guess, but you didn't run it, right? We are just talking about looking at the code.
Yeah, no.
What is it doing?
It will create a list and split the X object.
Yeah.
But then when you filter it, you don't specify a filter. So it will just take the blank space as a separator, but it will create maybe an extra item on the list.
This is your guess. So your guess is that it will create a list with A, B, C, and an extra item.
Perhaps, I don't know, because I don't know how many blank spaces.
There are 2. So here there are 2 blank spaces, here there is 1.
Yeah.
So what is it doing?
It's going to split every blank space.
Yes. So the output you say is going to be a list with A, then. So what are the items of the output list?
No, with A, B, and C, but I think it's going to be 4 items. Because of
4 items. Okay, so you see that we are discussing now already 5 minutes about this. And he is wrong. So this is the output. So do you know, if I have this list, how can I get this result in a way that everyone in this room understands how this is done?
But you could split that line in 4 lines or so, like being more explicit.
You can do this. Just this. So, this is one example of Stack Overflow horror. Because when I saw this line, I thought, well, what the fuck is this doing? I started thinking, as you did, what is this doing? And then I got messed up. I look at the documentation of the filter function, what actually does it mean when you pass down as a filter. And then at the end, because I was frustrated by the fact that I couldn't explain why this is the result, I googled the code and I found it in a Stack Overflow answer where someone was asking, how can I split a string with variable number of white spaces in the middle? And clearly, I mean, either it was a time where the split method of the string object in Python wasn't doing it. If you had tried to know, maybe 15 years ago, the split method wasn't so intelligent as it is now. The point is that, this is not really good. So all this example was just to let you understand why it makes sense to think about readability of code, especially as a scientist, because you, in 2 years, are going to read this and again don't understand what it is. And the problem is that instead of being at such a list that you can immediately try, if this is now 5 GB of data that are buried somewhere in an hard drive, in some drawer, in a lab you are not a member of anymore, then it's a problem. So, I hope I convinced you that it made sense to go through the pain of applying to this school. Yes. I usually, when I do it in Europe, now I have to explain all the things that Carlos told you yesterday, so I'm not going to repeat it, all the thanks and all of the things. We're going to do the thanks anyway later with the inauguration. So that's not needed anymore. But let's say one buzzword that is being around in the last 20 years is reproducible science, right? And now this is a good example of this. So reproducible may mean many things. So one thing is what now many journals start doing it is that when you submit a paper, you have to submit the code that generates the figures of the paper, for example, or the results. And this is a kind of reproducibility that I would call digital reproducibility. So you can reproduce the number exactly. But this is not the kind of reproducibility we care about as scientists. So if you talk about reproducing an experiment, for example, in a lab, what you actually mean is that if I read the paper, I should be able in a completely different lab with no connection with the lab that originally did the experiment to create a setup, do the similar experiment and add qualitatively similar results. They don't need to be identical, they are not going to be identical, but they should show the same effect, whatever, right? And with code, it's exactly the same. So we want to have code that when in 10 years, no one is going to talk about Python anymore because Julia has become the language the scientists are using, of course. And you need to port it. You are not going to be able to reproduce the numbers exactly. So what you actually will care is, I want to be able to read the code, understand what it does, and write it in a completely unrelated different language. So this is the objective of the school, among others. That you learn how to write code that can be understood by humans and rewritten in any other language you care about. So Python helps us with this because it's already a language in itself, relatively readable. But you need to put some effort to make it really readable. So this is not the effort. That's why don't use stuff, or at least not in my process. So I think we are done with this. That you have to be punctual every morning and be here at 9 exactly. I don't know, before 9, so that we start at 9 sharp. That's Jakob. Sorry, Carlos told you already, but I cannot. Yes, you can also. So Jakob was introduced. This is Dr. Jakob. What's your surname? Jakob Jordan. You can see now. So we are going to do the Git lecture together. Yes. You can sit down again. I'm going to sit down.
Okay, so every morning, be here before 9.
Yes, no, another thing is important. Why do you sit in pairs? So you sit in pairs and you don't have enough laptops, so that basically you have to work in pairs because there are not enough laptops otherwise. This is not because we didn't have the money. This is on purpose. So we want you to work in pairs. And what does it mean working in pairs? It means that when you have to write code, one of you is going to write the code and the other one is going to sit in the back and look and have the big perspective of what is going to be done. And then once in a while you switch. You are allowed to talk in the meantime. Actually, you are encouraged to talk about things. And if you're probably going to have, by switching pairs every lecture, so you will do the Git lecture fixed here, and then the next lecture you will switch. You will work with someone who may be more experienced than you or less experienced than you. And the idea is that then you use that. So if you are more experienced, you use this to explain it to the person that is less experienced, and by explaining it, you will learn it. You will learn that you didn't understand it exactly as good as you thought, because it's difficult to explain. So you will learn something. And the person who knows less will have someone that explains it, so that they will also learn something. So this is the idea of the peer programming. That's why you have to do it like that. A nice side effect is at the end of the school, you will know everyone personally. And we'll have maybe a couple of friends. So, let's start with Git. Now, I assume that everyone went through the introductory material, given the self-reported Git experience. Let's see. Given the self-reported Git experience, I'm assuming that 1/3 of you doesn't use Git regularly. Did you go through the introductory material? So do you know what Git is? Wrong question, because no one will ever say no, I don't. So I'll start the lecture, and then you will have to be brave enough to stop me if I say things you don't understand. It's important because all of the following lectures are going to use Git for everything they do. So that's why we do it as a first lecture. It's important that you get it. So if you don't get it, you'll have to stop. Or maybe you can ask your peer who you're working with if they can help. So there are many scenarios that are okay. You can now start opening look at your laptop. How many do you want to I'm doing now. Yes. Yeah. So, if you go, I hope you can all open the browser and go to the homepage of the school, go to the schedule, and then at the lecture, where the lecture is, you can click on it and you will land on the GitHub repo with the materials. So, I need your attention for a second. So, you go to the repo and you follow the instructions on setup. For this, so we will set up SSH keys. If you don't know what they are, just imagine this is a token for authentication with GitHub so that you can use it without having to use the two-factor authentication that now GitHub enforces on us. For that, you will need USB sticks where you will store the keys, and you will get the USB sticks now, right now.
Is anybody missing a USB stick?
Here.
Are you already distributed them? Is anybody missing one?
Okay. These USB sticks. Yeah. Not your.
No. We're gonna. You should use ours.
You should use ours. You should use ours. So, important thing is this USB stick need to come back at the end of the school. So you don't lose them. Let me repeat, they come back at the end of the school. So we have no money, so we need to recycle. So, set up, click on that link, and there are instructions how to create an SSH key, upload it to GitHub, put it on the USB stick, and then I will explain it how we use it. Yeah? So follow the instructions there. Another thing I forgot, do we have the stickers?
Yes.
So, another thing before you start talking, we have stickers in two different colors. So the pinkish one, there are two colors, but you have to imagine this is one color. Pinkish one and blue. Each pair will have one pinkish and one blue one. Blue means you attach it on the back of your laptop like this when you are finished with the exercise. In this case, it means you attach it when you are finished with the setup. If you have a problem and you want one of us coming over and help you, you put the pink one. So this is necessary so that you avoid screaming over the roof and ask for us. You don't need to keep your hand up for 10 minutes. And so you put this, we see it and we come, and then when you are finished, so that with your problem, you take it out. Okay? So this is an easy communication to avoid noise. And then I need the See the box. And then when you hear the sound, I'm asking for your attention. So it's, you stop talking. Okay? And now with all of this, can you please follow the instructions and then... Oh yes, every person should do it. So first, if your pair is Alice and John, first Alice does this and then John does it. Yeah? So everyone needs his own USB stick. And put up the stickers if you have problems. Okay? Everyone can go on the browser is like from
But it's usable?
yeah, it goes. Everybody can kind of.
I mean, there was something.
That's you start.
Yeah. You started the
¿Ya te la pones?
Just a couple of these commands. This I finished. And then we have to remember to upload something.
In the meantime, you speak to yeah. Yeah, but they should know. Yeah. Oh, no, you shouldn't have to. Now this copy is private and then you So when you're finished, remember to put the speaker up so that I see. Okay. Yeah, talk. Okay, guys. Okay, then of course, on the other end, because now, because with this, now with this in the I think that we're supposed to be so we but because of your Right? This is the first thing. Great. One. And now you're already have some. Yes, but I don't want you to see the so why don't you sit with that? Okay. And then brother. Yes. Okay. Okay. Just arrive. I don't want you to work alone.
Para hacerlo we are
So you finished the one? Finish it. Problem? So we are finished. Finally, we planned 10 minutes. So it took a bit longer. Yes, okay. So in the little test to be sure that now all the laptops are set up, if you hit the Windows key, do you see a kind of an orange background? If you don't see it, can you raise your hand? Very good. So all the laptops are installed properly. Yes. So now go back to the repo. I don't think you don't need to type the address. You just go to the schedule. You click on it. So the setup is done. Now with you, instead of going through Git commands one after the other, we are going to do an exercise together, which is an alternative to the typically very boring Git tutorial examples with files with one line, second line, hello, or this kind of stuff. So we are going to write something useful. A simple authentication system. You don't do it alone. This is so we're going to write a program that asks for username and password, and then stores the username and password in a database. And then when you ask to authenticate, it will ask you to give a username and a password and verify if the password is correct. Right? So this is what we are going to do. And what I want the script, the way I want the script to work, so I'm describing here now my expectations. This is typically what you would also do when you start writing a script for your own project. So what do I want to do with this script? Well, I want the script to ask for username and password. If the user is known and the password is correct, you bring successfully authenticated. Something similar you've just seen with GitHub now. If the user is known and the password is wrong, it should bring wrong password. If the user is not known, it should ask to add a new user to the password database. And if a new user has been added, store the updated database to disk. I'm saying here database, but don't be scared, this is just a file. We're not going to do any SQL or anything. So, and then now here we have our expected usage. Another thing that you will typically do, that you think about, okay, what kind of functions do I need? So I need a function that we will call getCredentials that will ask for username and password, right? Then I will need a function that will authenticate. It means check if the password that's been typed in corresponds to the right password in the database. I will need a function to add a new user. I will need a function to read the database from disk, and a function to write the database to disk. Okay, so now, and now I am not going to do anything on my own, so you are going to tell me what to do. Let's go to ASPP and let's go here. So let's start. Now, because we want to use Git, how do I start a new project in Git? Git init. So, and where do I do it? So when do I do it and where? In which directory should I be? Root directory is a bad idea. That's why I asked.
The root in the folder that you create, you simply create.
Exactly. So I created work. You see, yes. I created work. So inside this thing, I'm going to have my Git, all my files, and I do Git init within this directory. Yes. So I put it here, and then we're here. So Git init. And look that my prompt changed here. It's already showing me this. This is a Git branch. The branch we are in is going to be made. And in your laptops, if you type along, you will have something similar. Not exactly the same because your prompt looks different, but it's the same thing. So, so let's start, right? I will start the script. I will call it auth.py. And now let's start implementing our API. So we said we want. So we want a function that asks for username and password, right? Yes. And what was the name of the function? You remember the API we have here? You get credentials. So.
Do we have to do this in our computers or just on
No. You can type along if you want, but not in the repo that you just clone. You didn't clone my repo, right? You haven't used any Git until now, so you just create a new directory and work in it. You can type along. Yes, it's a good idea. Later in the exercise, you are going to clone the repo and work on the repo. But for now, just for you, you can play around with this. Okay, so how do I get input from the user? How does that work? Input. And then can you tell me what to write then? So what should I write?
Maybe a user input.
And then
Give an instruction there. User.
Then, is it ready? Is it enough? Why not? Do I need anything else? Well, okay, then let's say it's done.
Return the values.
That's a good idea. We want to return them, right? Ah, by the way, I didn't explain what I'm doing. So this is a terminal. I'm editing the file in the terminal with an editor that works in the terminal. You of course don't need to do that. You can use whatever editor is installed there. I think it's LATAM, which, by the way, you can take note that we changed the code editor because LATAM is not supported anymore. And I split the terminal in two, so here we can execute commands, and here we edit the file. Okay. Well, this is my special terminal. I can do it. I don't know. But yes, no, I have not. So this is good, and this is the terminal. Don't be confused, later. It's like two windows. So and here. So now, how do you run a Python script? Python. So you just say Python out, and then nothing happens. So there is a bit of a problem here. Why nothing happens?
You're not calling the functions.
I'm not calling it. So how do I call the function? I could do this.
Yep.
Now, well, let's do it. Let's do it. So it works. Now there are two things I don't like, so I'm not going to commit this until we fix these aesthetical problems. We need space here. And now run it again. So now it works. So now we have a version that does something. This is the right moment to start committing our changes, right? So how do I commit? But this is not okay. So I just write git commit. The file name you have to speak loud because they have to. If I do this, then I get an error.
Yeah, we haven't done that.
We have to add the file to Git. So for those who are not familiar with Git, Git is not going to track any file automatically until you tell Git that you want to track the history of a certain file. So at the moment, Git is not tracking any file, and if you say Git status, it will tell you that I have a branch name. There is no commit in our repo until now, and there is an untracked file. So this file, Git doesn't know anything about, and it tells you even that if you say Git add file, then it will start tracking it. So this is what we have to do once. Git add out. And now if I say Git status again, it tells me that if I do a commit, so changes to be committed, if I do a commit, this new file will be created. So I say git commit, and now you see that it opens an editor where I am supposed to type a commit message. Right? So we write first implementation of save and done. So now git tells me that I'm on branch main and there's nothing to commit. Working tree is clean means that there are no changes that have not been recorded. If I say, so how can I look at the history of the commits I've done? What is the command? How do I look at the commits in Git? Git log. And in our case, it's pretty easy because there's only one commit, right? So it's a commit. This is a unique identifier for that commit. I don't need to remember that. It has an author, it has a date, and it has the commit message. how can I see what have I done in that commit? I want to see the changes that I've done in that commit. If I say git diff, nothing happens.
But you have to put the name of the file.
Still nothing happens. Loud. So now we are start saying random things. No. No, with the name of the file even, it's not going to happen. Guys, you say git show. Git show, and then the name of the commit. Okay, that it could be head, but actually the name, if you want to do it properly, because in the future we will have more commits. I can copy the name of the commit and then I say git show that thing. And this will show me the diff of that commit. Which in our case is actually nothing because it just tells that it's added a new file. Well, sorry, no, it's not nothing. It's just it's everything we have in it. So, and we have added these lines to this new file. Right? Okay, so git show, not git diff. Git diff is going to be useful. We use it now in the next second, but it's not about looking at history. So now we have made credentials. What do I need? I think probably the next useful thing would be to save the database on disk. So we define the function def write.
We would like to write, but we don't know how to use Vim.
You shouldn't use Vim. You could use another editor.
There is a provision to be told.
And don't blindly type along. There's no need to type these things. It's just for me, I'm preparing. You don't need to do anything. So, we need to implement something to write the database to disk, to read it, and to add new users. Until then, there's not much we can do with this script. But before we do it, there is one thing that I don't like about this script. And the fact that we call the function here, this is not nice. Because this means that when in the future this script will become part of a bigger library that we are going to write, and we are going to import some of these functions into another script, then this function is going to be executed every time we import this script. This is not what we want. We want to execute this function only when we call the script explicitly. So how do we do it in Python? To write a script where we have a part that gets executed only when I call the script and not when I import it. Can you elaborate?
Making a class?
No. Making a class is way too complicated. It's doable, but it's not going to help. So, have you ever seen this thing here? Have you ever seen this?
Yes.
Yeah. So this makes everything that is below this within this if is only executed when I run the file, and it's not executed when I import it. So to verify, we can now. I'm splitting the terminal again. Don't get confused with it. I just use it now to execute. So if I say git so Python out. As expected, it's asking me for things, but if I go into Python and I import that script, nothing happens. Yeah, and if I want to call the function, I have to say get credentials, and then it will work. So you understand the difference? Yeah. So when we call it, it will execute it, but when we import it, it will not execute it. So this is a change that is worth having a commit for. Right? So now we want another commit, and now I don't have to explain everything I do because we have done it already. I could say this. Actually, the best thing is you always say git status before starting to just check that the stuff you are going to add is the stuff you really want to add. So here git tells us, yes, you modified auth, and now I can use git diff. If I use git diff, I see what I added. So I have removed this line, added this comments, and then this new section here, right? With git diff. So what is Git showing me when I saw Git diff? The difference between what? Too many people simultaneously? You, but louder.
The difference between your actual file and the previous version.
Very good. This is what. So the difference between the file that is on disk at the moment and the file as Git as the last commit that Git knows about. Yeah? So, and now I commit, and I can use this short way of specifying the commit message directly in the command line without having to open the editor. So, why did it protect? And then if I pass the name, I don't need to add in this basically. If I pass the name, it means that I want to commit changes on that pattern. So now if I say git log, I see 2 commits. And how do I see the difference between this commit and this commit? Someone? The experts? How do I see the difference between 2 commits? Yeah, git diff and then? Well, what do you think? I mean, it cannot be too. What? The number, yeah. So, I mean, if Git would be intelligent, it would be just that, no? Right? Well, it is. It's just in the wrong direction, right? So it's now showing me how to get from what I have now to the version to the older one. But, so it means that the 2 numbers have to be flipped. Yeah, so git diff, if you don't say anything, it shows the diff between what is on disk and what was the last commit. Or you can specify explicitly which commits you want to compare. Yeah. So, now let's go back to our function here. No, actually I would like, let's say before we do that, because we have still maybe 10 minutes. So, yes, so we could go to the first scenario. Now, I could go on improving this script and we will do it later. But now, all I'm doing is just on my laptop, right? So now, if typically this is not the setup you want to have, right? Because your script needs to be somewhere else too. Otherwise, if you lose your laptop, if they store your laptop, if the hard drive breaks, then everything is gone. So the typical situation you will have is you have some kind of remote repo somewhere, correct? Where you store your file. And in our case, we are going to use GitHub. At the university, you may have some institutional Git thing, GitLab typically, but it could be anything else, right? So how do I go about now sharing, putting this stuff I've done on a remote repo? How does that work? Push? Yes, but what do I push where? The repo doesn't exist, I just created.
Remote or something like that.
Yes, I can add a remote, but where? What remote? Where is it? So how do we do it? I mean, because this is, yeah, it's going to happen, right? So you start a new project, you create a Git repo, and how do we do it? How do I go about it? So let's say first that I have to log it on Git. Yeah, so I do it. You don't need to do it. So, and now everyone will see my tricks for, well. Don't look. Ah! That's it. Wait. Where the fuck is it? Sorry. Go away. Oh, I still sharing the screen. Wait.
Free software.
No, that's not free software. This is a stupid GitHub. So that's good. Now you can come back. I hope it works.
Also sharing screen.
Yeah, no, but I didn't try to the password explicitly. Okay, we are back. We are here, and I go to my account. So I will create a new repo. You don't need to type that, yeah, don't do it, because we are going to work with our remote later, so you don't need to do this. And then I will call it Git ASPP LATAM, and it's a public repo. We want to work in open source, right? So you typically will have public repos. I will not add a git ignore, I will not add a license for the moment. So I have a new repo, and this is the address of the repo. So how do I connect now my local repo here? So this guy here with that one on GitHub. You know that? You said git remote, so this is the right command. And then we add the remote. We give it a name. The typical name is origin. This is what the default will be if you clone an existing repo. It will call that remote origin. So that's why now when we do it manually, we also call it origin. And the address. Now, if I say git remote -b, it will tell me that I have this remote, and now I can push to that remote. And how do I, so is git push enough? What does git, do you know how to use git push with some arguments? So what the arguments?
You have to say from where and what.
Very good. So git push not from where but to where. Where do you want to push? Well, to the thing we just created, origin. And what do we want to push is the name of the branch. And in our case, it's main. And it tells me that pushes to GitHub, to this remote. It pushes the branch name. It is a new branch, it didn't exist, of course, because we created an empty repo. And now if I go on GitHub, look here, I reload the page. Now is my file. Okay, so now we have a remote. And we can share our work with Jakob. Because now Jakob wants to help us implementing some things. Do you want? Well, you don't want? Could you, and maybe before he does it, so now I've shared my work on the internet, so in principle anyone can start using it and then maybe may have ideas how to improve it, right? So, just that you, so that you see I go to the repo again, here. In the repo, you have some features, I call them scenarios, where you see a scheme of how the stuff works. So every dot is a commit, and time goes in this direction, and Now you can ignore the branches now because we don't do that. So what we have now is a series of commits in a line, right? Just on my laptop. This is the first scenario we have. This has been the first 10 minutes we have done. Now the second scenario is the one where I have a remote on GitHub. And this is the way it looks. I have to make it a bit smaller. Otherwise it doesn't fit. So, this is the scenario we have now. Ignore the branches for the moment. So we have on our laptop the same thing we had before, but now we have added a remote. This lives on GitHub. Its name is origin, and this line at the moment corresponds to this line. Right? So now, of course, if let me forget the comes. I think we have another 5 minutes, more or less, right? So I will do another commit on my own and then pass to Jakob. Let me add some documentation to this function. It's not very interesting, this, but now git status tells me that I have to modify the file. With git diff I can check what I'm doing. I've added one line with documentation. So let's commit this. And now I have 3 commits, 1, 2, 3, right? And on GitHub, if I go back to the repo here, I still have just 2 commits here. So how do I synchronize these 2 things so that what I've done on my laptop is available on GitHub? No, GitHub will commit, we just done. So git push, right? And during the school, I wanted to always specify also these other arguments. Even if git push now, from now on, would know automatically that if I can do this, and it will still assume that I want to push main to origin. But do it explicitly because there will be situations during the school and in your scientific life anyway, where these 2 arguments have to be given explicitly because you are pushing somewhere else. So it's always nice to be explicit about where to push. So I'm pushing, and now the commits are here. So what we're going to do after the break is that Jakob is going to help us now develop this. So we will have a situation where we have an additional developer, and how do we put the things together? Right? I'm on that.
Right, guys. So we will now go to the inauguration. Please, you can just go out and we will find a seat here in the room next to us. And then we will come back. You can leave all your stuff here, just bring yourselves. Right.
These are ways this is
Buenos días. Buenos días a todas, a todos. Saludo a nuestro señor rector, doctor Enrique Grado a todos. Saludo a la doctora Ofelia Angulo Guerrero, secretaria de Educación, Ciencia y Tecnología e Innovación. A la doctora Ofelia Angulo Guerrero, secretaria de Educación, Ciencia y Tecnología. Las autoridades universitarias invitados de México, así como a las autoridades universitarias invitados que nos acompañan. Hace unos meses me contactó la doctora Rosaura Ruiz. En ese momento, la titular de la Hace unos meses me contactó la doctora Rosaura Ruiz. En ese momento, la titular de la Secretaría para invitar a la DGTIC a participar en la administración y organización del proyecto. Para invitar a la DGTIC a participar en la administración y organización del proyecto. Desde la iniciativa se desprende, desde esa iniciativa se desprende la primer desde la iniciativa se desprende desde esa iniciativa se desprende la primer escuela de programación científica avanzada. En aquel momento vislumbramos que el proyecto tendría un gran impacto entre la comunidad estudiantil. En aquel momento vislumbramos que el proyecto tendría un gran impacto entre la comunidad estudiantil porque creemos y promovemos el uso eficiente de la tecnología en todas las áreas del conocimiento. Porque creemos y promovemos la convocatoria para participar en todas las áreas del conocimiento organizada por la SECTE. La convocatoria para participar en esta escuela de verano tuvo un gran impacto organizada por recibimos alrededor de 655 solicitudes, tuvo un gran impacto, de las cuales alrededor de 655 diferentes instancias universitarias, de las cuales se seleccionaron a 30 participantes. La elección de los alumnos fue hecha por un comité académico, nuestro aliado en de Advanced Scientific Programming. Esta escuela de verano ofrecerá a los participantes un repertorio de habilidades. Esta escuela de verano ofrecerá a las participantes su gran colaboración en el diseño de los contenidos de esta escuela de verano y por ayudarnos a reunir a los expertos internacionales que impartirán los distintos temas que se abordarán. Muchas gracias, doctor. Los profesores con los que contaremos proceden de España, Alemania, Suiza, Dinamarca, Estados Unidos y Polonia. Quiero agradecer también al equipo de GTIC, mis compañeras y compañeros que durante esta semana ofrecerán acompañamiento tecnológico, científico y académico a los instructores y participantes en la escuela para llevar a cabo las actividades de los programas. Muchas gracias, compañeras, compañeros. A todos los participantes sean bienvenidos a una jornada de intensa capacitación que arranca el día de hoy y concluye el próximo sábado 1 de julio, aquí en las maravillosas instalaciones de la Unidad de Seminarios Ignacio Chávez, doctor Ignacio Chávez, de nuestra universidad. Estoy seguro que formar parte de esta primera generación marcará de forma importante su desarrollo científico a todos ustedes. Enhorabuena y muchas gracias por estar aquí presentes. Buenos días a todos. Gracias.
Escuchemos la intervención del doctor Carlos Echeverría Cerur.
Hola, ¿qué tal? Buenos días a todos. Doctor Enrique Grave Vigers, rector de la UNAM. Doctora Jesús Ofelia Angulo Guerrero, secretaria de Ciencia, Tecnología e Innovación del Gobierno de la Ciudad de México. Doctor Leonardo Lomelí Vanegas, secretario general de la UNAM. Doctor William Lee Alardín, coordinador de la investigación científica de la UNAM. Doctora Rosaura Ruiz Gutiérrez, investigadora de la Facultad de Ciencias y responsable de la organización para ASPP en Latinoamérica. Doctor Luis Agustín Álvarez y Casa Longoria, secretario administrativo de la UNAM. Doctor Héctor Benítez Pérez, director general de Cómputo y Tecnologías de la Información y Comunicación. Muy buenos días tengan todos ustedes, todas y todos ustedes. Para mí es un gran honor y un privilegio regresar a la UNAM, a mi alma mater, después de un periplo de 10 años de vivir y estudiar fuera de México. Sinceramente, es muy emocionante volver al campus y a este vivero alto que forma parte de mi vida desde la infancia, que lo visitaba con mis padres. Permítanme presentarme. Mi nombre es Carlos de Echeverría Serur y me congratulo de que la idea de traer esta escuela a México se está convirtiendo en una realidad gracias al apoyo de muchas personas que no menciono para no pecar de omisión. Sin embargo, no puedo dejar de agradecer a la doctora Rosaura Ruiz el entusiasmo y con el que adoptó este proyecto desde un inicio. Para mí, regresar a la UNAM con un proyecto como esta escuela es un sueño materializado. El contribuir a una institución que tanto influyó a mi formación e historia es sumamente gratificante. Tengo la certeza de que este proyecto será sustancial en la formación de una nueva generación de jóvenes científicos de la UNAM y también se beneficiarán jóvenes de distintos estados de la República Mexicana y de América Latina. Después de graduarme de la Facultad de Ciencias como físico y al estar cursando mis estudios doctorales en matemáticas en la Technische Universität Berlin, tuve la suerte de encontrarme con la escuela Advanced Scientific Programming in Python, o ASPP por sus siglas en inglés. Dicha escuela fungió como un faro de luz en el empeño por alcanzar el doctorado. Me explico. En mi formación, la computación no formaba parte principal de los planes de estudio. Sin embargo, toda mi investigación se apoyaba fuertemente en el uso de la computación para ejemplificar teoremas en base a distintos algoritmos. Mi formación en esta área fue mayormente autodidacta y siempre tuve la sensación de que algo me faltaba para hacer mi código más abierto, entendible y competitivo a nivel mundial. Es ahí cuando solicité participar en la 11ª edición de la escuela ASPP en Europa. Los beneficios fueron inmediatos. Los temas aprendidos en la escuela me dieron las herramientas necesarias para lograr estructurar mi código de manera profesional. Ese logro, en la parte computacional de mi investigación, me dio la motivación necesaria para complementar mis aportaciones teóricas con los ejemplos computacionales necesarios. Hoy en día utilizo dichos conceptos y herramientas en el día a día de mi trabajo en la Humboldt-Universität Berlin. Estoy seguro que los estudiantes que hoy inician este curso, aquí frente a nosotros, tendrán una experiencia similar a la mía, ya que no estoy solo en esta experiencia, sino que la lista de egresados de ASPP crece año con año con magníficos resultados. En esta primera edición de la escuela para nuestro continente, tuvimos más de 600 solicitudes de estudiantes en México y en varios países de América Latina, como Colombia, Perú, Costa Rica, Cuba, Chile, Uruguay, entre otros. Después de una revisión exhaustiva, se redujeron las solicitudes a un número de 135 solicitudes completas. Parte de esta reducción en el número se debe a que tuvimos que dejar de lado las solicitudes de los estudiantes de licenciatura y nos enfocamos en las estudiantes de posgrado. Dicho sea de paso, el alto interés de los estudiantes de licenciatura muestra, como lo acabamos de señalar, un vacío, una necesidad compartida por los jóvenes científicos desde los primeros años de su carrera. Parte del impacto y la influencia de esta escuela radica en su cuerpo docente. Los instructores forman parte de una generación muy especial de científicos globalizados. Estos científicos utilizan la filosofía open source o de acceso libre para compartir sus conocimientos a un auditorio mundial. Es decir, con esta filosofía y las herramientas que conlleva, no es necesario comprar software privado para hacer investigación de punta, sino que se apoya en la comunidad científica global para desarrollar herramientas de libre acceso sin costo. No puedo dejar de poner de relieve la importancia de esta filosofía para el desarrollo de los científicos en los países de América Latina. Cada uno de los docentes, más allá de ser investigadores de punta en cada una de sus áreas, son parteaguas en una nueva generación de científicos que utilizan la computación aprovechando todo su potencial. Y debemos dimensionar lo que esto significa cuando hablamos de computación. Espero que estos valores, muy a la par de la conciencia del mundo natural en el que vivimos, proliferen y sean adoptados por las nuevas generaciones de científicos. Incluso podríamos decir que la realización de esta escuela le da vida a la frase «Ciencia sin fronteras». El reunir a científicos de varios países de Europa y Estados Unidos para trabajar en México con estudiantes de varios puntos de la República Mexicana es verdaderamente un ejemplo de la colaboración nacional e internacional. Espero que esta escuela sea un punto de partida para generar otras en la región y que se repliquen y fructifiquen estos esfuerzos innovadores y sean un ejemplo para seguir en un futuro cercano por el bien de los científicos en México y en América Latina. Solo quiero terminar diciendo que en todas partes donde he estudiado y trabajado, reconozco mis raíces en mi alma mater, que es la UNAM, a quien agradezco todo el apoyo brindado junto con el SECTEI y a todos los miembros del Presidium por su invaluable apoyo. Quiero también agradecer a todos los que apoyaron en la realización de este proyecto, en especial a la maestra Patricia Garcés Natera y al ingeniero Federico Hernández Noranca, con quienes trabajé estrechamente para que esta intensa semana de trabajo que tenemos adelante sea posible. Finalmente, y desde luego muy importante, agradezco a cada uno de los científicos de ASPP por haber hecho el esfuerzo de venir a México y conocer y trabajar en esta noble institución. Muchas gracias.
Tiene la palabra el doctor William Lee Alardín.
Muy buenos días. Señor Rector, con su permiso. Doctor Angulo, muchas gracias por acompañarnos. A los distinguidos colegas del Presidium, gracias por estar con nosotros. Pues muy buenos días a todas y todos ustedes, participantes de esta escuela, y muchas gracias, doctor Echeverría, y a todo el equipo por la organización y la realización para llegar a este punto, porque obviamente hubo mucho trabajo detrás en las últimas semanas y meses para arrancar hoy la escuela. Muchísimas gracias por sus palabras. Yo destacaría tres aspectos de una escuela como esta en términos de la proyección que puede tener para adelante. El primero es que esta es una escuela de cómputo científico y veo gente, y me da mucho gusto ver gente de diferente fondo y formación en cuanto a la disciplina que los trajo aquí para usar esto como una herramienta para lo que ustedes quieren resolver. Porque la gran mayoría de los problemas que tenemos ahorita requieren de enfoques multidisciplinarios, tanto en salud como en medio ambiente, como en materiales, como en energía, y el cómputo científico es sin duda una herramienta para todos ellos, incluyendo los problemas sociales que se derivan de todos estos problemas, si quieren, técnicos. Pero se tienen que abordar de una manera integral, porque si no, no vamos a lograr resolverlos, ni siquiera plantearlos correctamente. Entonces, el aspecto multidisciplinario sí me parece muy importante. El segundo es que, bueno, estamos en temporada de escuelas de verano. Le comentaba al doctor Benítez y al doctor Álvarez y Casa hace un momento cuando estábamos allá afuera, que ya perdí la cuenta, creo que es la tercera o cuarta inauguración de escuela de verano a la que asisto en las últimas semanas, y todas tienen un enfoque que puede ser útil si se ve desde el eje de la sostenibilidad y los objetivos del desarrollo sostenible de la Agenda 2030 en cuanto a los temas que atacan y la manera en la que los atacan. Tienen también un factor integrador regional y nacional, por supuesto, y en algunos casos global, en la gente que participa, en la gente que las organiza y que viene a dar una presentación, un curso, un taller, una enseñanza, y como por lo tanto en los efectos que va a tener hacia afuera. Lo que me lleva al tercer punto. Ustedes van a estar aquí una semana, tengo entendido, de aquí al sábado. De aquí al sábado, porque el doctor Benítez es muy… de aquí al sábado. Y sospecho que algunas de las personas que están aquí sentadas ya se conocían desde antes, tal vez algunas no. Pero lo que puedan aprender y desarrollar y absorber y llevarse después del sábado próximo en cuanto a sus relaciones y lo que aprendan y lo que puedan establecer con las demás personas que están en esta escuela, les puede servir para los próximos 5, 10 y 20 años en términos de relaciones personales y de lo que puedan hacer después. Ya han estado en otras escuelas, me imagino, y saben un poco de lo que estoy hablando. Tal vez si hubiera estudiantes de licenciatura dirían de qué está hablando, pero dado que ya dijo el doctor Echeverría que se centraron básicamente en estudiantes de posgrado y ya gente que tiene carreras en desarrollo, sabrán de lo que estoy hablando. Lo que pueden hacer aquí puede ser útil a futuro en iniciativas que a ustedes se les ocurran dentro de unos años, no necesariamente ni siquiera la que estén pensando aquí, pero de saber que alguien que estuvo aquí y algún tema que se tocó aquí les puede resultar útil en una red de trabajo, de colaboración académica y de formación de personas para los relevos que sigan en un futuro. Entonces, sí les invito a que hagan eso. Si ya conocen gente aquí, no se sienten con esa gente a comer, siéntense con alguien más, alguien que no conocen, y platiquen sobre algo que no han hecho con ellos. Muchísimas gracias al comité organizador, muchas gracias a todas y todos ustedes por estar aquí, y les deseo una muy exitosa escuela. Muchas gracias.
Escuchemos las palabras del doctor Leonardo Lomelí Vanegas.
Muy buenos días, doctor Enrique Graue Vigers, rector de la Universidad Nacional Autónoma de México, doctora Ofelia Angulo, secretaria de Educación, Ciencia, Tecnología e Innovación de la Ciudad de México, bienvenida, doctora Rosaura Ruiz, doctores William Lee, Luis Álvarez y Casa, Héctor Benítez. Me da mucho gusto saludar también al doctor Carlos Echeverría, gracias por mantener su vinculación con nuestra universidad. Saludo a la doctora Raquel Cerur, embajadora de nuestro país en Ecuador, profesora de la Facultad de Filosofía y Letras, y por supuesto a todas y a todos ustedes que participarán en esta escuela de verano. No cabe la menor duda de que hoy en día el cómputo ha cimentado sólidamente su posición, junto con la teoría y la experimentación, como el tercer pilar de la investigación científica. Los científicos de todas las áreas de las ciencias dedican cada vez más tiempo a escribir, mantener y depurar códigos de software. Aunque las técnicas para hacerlo de forma eficiente han evolucionado y son comunes tanto en el ámbito de las ciencias computacionales como en el de la industria, son pocos los científicos que han recibido formación para utilizarlas. Como resultado, pasan demasiado tiempo escribiendo código de investigación deficiente y reinventando la rueda en lugar de consagrarse a las labores de investigación. Este fenómeno se observa en todos los ámbitos de la ciencia que no han recibido una educación formal en cómputo, desde la biología, las matemáticas, la física o la química, hasta la psicología, la medicina, la sociología, y me consta que también es el caso de la economía. En esta escuela de verano se impartirá una selección de técnicas avanzadas de programación y mejores prácticas que son estándar tanto en la ciencia como en la industria computacional, pero especialmente adaptadas a las necesidades del científico programador común. Las clases están diseñadas con la finalidad de ser interactivas y dar a los alumnos tiempo suficiente para adquirir experiencia práctica directa con los materiales. Los alumnos trabajarán en parejas durante todo el curso y formarán equipos para poner en práctica los conocimientos recién adquiridos en un proyecto de programación real. Con la esperanza de fomentar la cooperación, colaboración y proliferación de la información que se enseñará en la escuela, se emplearán herramientas open source o de acceso libre. Asimismo, se utilizará el lenguaje de programación Python en todos los cursos. Python no solo funciona como un lenguaje de programación sencillo para principiantes, sino lo que es más importante, es sumamente eficaz, habiéndose vuelto muy común en simulaciones científicas y análisis de datos en todas las áreas de la ciencia. Se trata además de una herramienta de bajo costo que ha brindado competitividad internacional a los científicos de todos los países latinoamericanos. Esta escuela constituye de tal manera un fuerte ejemplo de cooperación y colaboración nacional e internacional, como puede observarse tanto en su grupo de estudiantes como en el de los docentes. En lo relativo al estudiantado, su composición proviene de más de 10 diferentes institutos al interior de la UNAM, 4 universidades del resto de nuestro país y 2 internacionales, ambas en Ecuador. Los docentes, por su parte, proceden de 2 instituciones, universidades y centros de investigación en 6 países de Europa y Estados Unidos. La diversidad en la formación teórica de los estudiantes, al mismo tiempo que pone en evidencia la problemática que intentamos remediar por medio de estos cursos, rinde también testimonio del papel que juega la computación al interior de la ciencia moderna, el de proporcionar un lenguaje común, como un hilo conductor vinculante a todas las disciplinas científicas. Cabe enfatizar, además, que esta escuela se esforzará por conseguir un grupo de estudiantes internacional y equilibrado en cuanto a género en sus siguientes ediciones. Por todo lo anterior, no me queda sino expresar mi entusiasmo ante la realización de este curso de verano, que repercutirá positivamente, como esperamos, en las labores de investigación de las científicas y los científicos de América Latina. Muchas gracias.
Solicitamos a la doctora Jesús Ofelia Angulo Guerrero nos dirija unas palabras.
Muy buenos días. Todavía creo. Doctor Enrique Graue, muchísimas gracias por esta extraordinaria anfitrionía. Este lugar es maravilloso. No podríamos estar en un mejor lugar hoy en día. Muchas felicidades a todas las personas aquí presentes por estar en este escenario tan maravilloso. Difícilmente se puede igualar otro lugar. Muchísimas gracias, señor rector. Saludo a todos los colegas, amigos que hacen posible esta escuela de verano y muy particularmente a la doctora Rosaura Ruiz Gutiérrez, una fuerte impulsora de la ciencia, de la vinculación, de la colaboración y de hacer lazos internacionales. Muchísimas gracias, doctora, por permitirnos ser parte de esta escuela de verano que hoy inicia. Traía un mensaje escrito, pero con el permiso de todos ustedes voy a omitirlo. Quiero que recordemos hoy un poco lo que desde la Secretaría de Educación, Ciencia, Tecnología e Innovación, el gobierno de la Ciudad de México ha venido empujando y mucho de ello bajo el liderazgo de la doctora Rosaura Ruiz. Si no es que todo. Para empezar, en todos los niveles educativos se han implementado estrategias de apoyo, no solo apoyo directo pecuniario, sino apoyo de fomento a la ciencia, fomento a la investigación desde los niveles más básicos. Me refiero a los talleres Sor Juana Inés de la Cruz. Los talleres Sor Juana Inés de la Cruz tienen un componente de programación libre porque se aplica a la Raspberry, las computadoras esas chiquititas, a través de las cuales se enseña a los niños y niñas desde tercero, cuarto, quinto, sexto año de primaria y toda la secundaria a empezar a identificar solución a los principales retos que enfrenta la ciudadanía en esta maravillosa Ciudad de México. Problemas como sismos, problemas como escasez del agua, problemas como la biodiversidad, la pérdida de la biodiversidad. Entonces, desde muy pequeños, estos niños y niñas empiezan a trabajar con la tecnología y creo que vale la pena recordar esto en este contexto de la escuela de verano ¿cómo le llaman? ¿SAPP? ¿Está bien? ¿SAPP? ASPP. Muy bien. Advanced Scientific Programming in Python. Muy bien. es pertinente recordar esto y es maravilloso, es motivo de mucha alegría saber que los niños no solo tienen acceso, como decía al principio, a una beca que hoy les permite alimentarse mejor y ir mejor preparados a las escuelas a aprender los conocimientos fundamentales de ese nivel educativo, sino que tienen también el acompañamiento de conocimiento científico. En media superior casi se duplicó la matrícula en este nivel educativo, con apenas 6, digo apenas porque se inició el Instituto de Educación Media Superior en esta administración con 22 planteles y hoy cuentan con 28. Entonces, en ese número reducido, digamos, de nuevos planteles, se pudo duplicar la matrícula de atención a los jóvenes de educación media superior. Y quiero compartirles 2 cosas que hizo la doctora Ruiz en este nivel educativo para fomentar la parte científica. Primero hizo una escuela de verano para estudiantes de media superior y maestros de esta institución en el Sinvestap, lo más cercano que teníamos. Entonces fueron 15 días ahí y muchos de ellos salieron diciendo, yo quiero venir a esta escuela en el futuro. Eso significa para ellos, número 1, terminar la preparatoria, que no es una cosa menor, o sea, es una cosa compleja porque el porcentaje de egreso de esa institución es un reto para esta administración. Segundo, ir a la universidad. Y tercero, llegar al Sinvestap, porque el Sinvestap solo ofrece estudios de posgrado. Entonces es un camino largo todavía por recorrer, pero se empieza por la decisión. Y plantar esa semilla, tanto en maestros como estudiantes, es un avance importante. En un segundo programa que hicimos, y es el segundo año que lo hicimos, fue enviar a un grupo de profesores del Instituto de Educación Media Superior que imparten física, la materia de física, al CERN. Están hoy tomando clases en el CERN 18 profesores de física, de computación y de matemáticas en el CERN. ¿Ustedes saben? Por supuesto que saben lo que eso significa. Les cambia la vida a esos profesores y se convierten en motivadores de la ciencia en las nuevas generaciones, en los jóvenes que están en media superior. Es el segundo grupo del Instituto de Educación Media Superior que va al CERN. Y hemos sido testigos desde la primera generación y ahora, porque lo escuchamos de ellos, que había sido para muchos de esos profesores de física un sueño, algo que pensaban que nunca iban a poder alcanzar. Y hoy lo están haciendo realidad. Hoy están en Ginebra esos profesores. Es maravilloso, sencillamente maravilloso, transformador, único, muy especial. Media superior, superior. En el nivel superior, en el tipo de educación superior, se crearon en esta administración 2 nuevas universidades. La Universidad de la Salud, que atiende hoy jóvenes que se forman, se interesan en llegar a ser médicos, médicas, enfermeros, enfermeras de toda la República, de las 32 entidades federativas. Vienen a la Ciudad de México a formarse y hoy en día tienen casi 3,000 estudiantes formándose ahí y tienen apoyo para encontrar vivienda, una alimentación, hay un comedor en la universidad y con 11 pesos desayunan, comen y cenan todos los días. También una gran oportunidad para muchos jóvenes que vienen del interior de la República. Por supuesto que la mayoría de los estudiantes en la Universidad de la Salud son de la Ciudad de México y del Estado de México, pero algunos vienen pocos también de las entidades federativas. Y la segunda universidad es la Rosario Castellanos. Le llamo ahora universidad porque apenas el 2 de junio pasado se publicó la reforma a la Ley de Educación de la Ciudad de México, en la que esta universidad pasa de ser Instituto de Estudios Superiores de la Ciudad de México, Rosario Castellanos, a Universidad de la Salud, pero no solo cambia el nombre, sino que pasa de ser un organismo desconcentrado a un organismo descentralizado. Esto le permite autonomía técnica, autonomía académica, autonomía de gestión, administrar sus propios recursos, y esto es un gran avance en la administración y en la autonomía académica de la universidad. Puede generar sus propios espacios colegiados, etc. Esa universidad se creó en abril del año 2019, apenas un año antes de la pandemia. Luego tuvimos 2020 con la pandemia, 2021 con la pandemia, parte de 2022, y estamos a mediados de 2023. Con todo eso en mente, escuchen los alcances que ha tenido esta universidad. Ofrece hoy en día 22 licenciaturas, 5 especialidades, 6 maestrías y 3 doctorados. Y atiende una matrícula de casi 40,000 estudiantes. Eso en ninguna parte del mundo se ha visto antes. Es la primera vez que mundialmente esto sucede. Pero no solo ha crecido en cobertura, ha crecido en oferta académica, sino que tiene todo el respaldo académico porque se creó en el contexto de la Red ECOS, de Educación, Ciencia, Tecnología e Innovación, de la cual forma parte la Universidad Nacional Autónoma de México, la Universidad Autónoma Metropolitana, el Instituto Politécnico Nacional, y estas grandes instituciones, principalmente la UNAM, dio todo el respaldo a esta universidad, la Universidad Rosario Castellanos. Entonces, la solidez académica con la que esta universidad ha crecido tiene todo el respaldo de estas importantes universidades de la nación. Así que estamos muy contentas de que podamos realizar este tipo de proyectos en los que todos ganamos. Ganan los jóvenes, ganan las instituciones, gana la ciudadanía, crecemos juntos a través de la colaboración. Coincido totalmente con el doctor Lee y con el doctor Lomelí, en el sentido de que la colaboración interinstitucional e interdisciplinaria hoy en día cobra la mayor relevancia, porque los problemas que enfrentamos de cambio climático, de la salud, requieren de las aportaciones de todas las disciplinas y de todas las instituciones. Y no quiero cerrar este recordatorio de las diferentes políticas públicas de la Ciudad de México sin hablar de los puntos de innovación, libertad, arte, educación y saberes. Quizá no todas las personas aquí presentes sepan lo que es esto, son los pilares, son centros comunitarios que en más de 50 años de esta ciudad se habían creado apenas 30 centros comunitarios. Hoy, en esta administración, tenemos 293 centros comunitarios. ¿Qué ofrecen estos centros comunitarios? Pues acceso a computadoras, acceso a internet gratuito, acceso a la educación en todos los niveles y tipos, con acompañamiento pedagógico. Hay personas ahí siempre presentes que ayudan a las personas adultas que no han terminado la educación básica, que puedan, con el apoyo del INEA, terminar la primaria y la secundaria, pero también con el programa Bachillerato en Línea, que personas que no han podido asistir presencialmente a una institución lo puedan hacer. Es decir, que son centros comunitarios que ponen a la educación en el centro, en el medio de la política, con las escuelas, las ciberescuelas, y que en los últimos 2 años se ha acompañado de un programa de certificación también en esquemas de programación, como Python. Al nivel más básico, como dijo el doctor Lomelí, al nivel sencillo, al nivel empezar una inducción, digamos, a la programación de Python. Y ya luego pues vendrán a los niveles a los que ustedes llegarán después de esta escuela de código. Sin lugar a dudas que uno de los programas más importantes de la red de ecos de educación, ciencia, tecnología e innovación, coordinada, por supuesto, por la doctora Ruiz aún en el presente, y que ha sido un modelo para el gobierno federal en la creación del espacio común de educación superior, mandatado en su Ley General de Educación Superior, es el tema de la movilidad académica. El programa de movilidad académica es sumamente importante y esta escuela es un ejemplo de ello. Las relaciones que se desarrollen de esta semana de trabajo entre todos serán, espero yo, de largo aliento y serán también para beneficio de sus propias líneas de investigación y de las instituciones que ustedes representan. Así que enhorabuena por esta escuela de verano, Advanced Scientific Program in Python, bien, y que puedan sacar también oportunidad para visitar esta maravillosa universidad, la Universidad de la Nación, que hoy los recibe con los brazos abiertos. Muchísimas felicidades a todos y muchas gracias.
Escuchemos a continuación los comentarios del doctor Enrique Graue Vigers, rector de la Universidad Nacional Autónoma de México.
Bueno, pues ya les di los buenos días a todas y todos ustedes. Y ya se dijo todo, me dejaron muy poco, hasta las notas dejé por ahí, efectivamente. Yo creo que lo que me toca es agradecer. Empezando agradeciendo a la señora secretaria de Educación, Ciencia y Tecnología de la Ciudad de México, a la doctora Angulo su presencia. Yo entiendo lo complicado de la agenda y estamos doblemente agradecidos. Al presidium de universitarios que nos acompaña, el doctor Lomelí, secretario general, al señor coordinador de investigación científica, al doctor Álvarez Casa, secretario administrativo, al señor director de cómputo y comunicaciones de la universidad, el doctor Héctor Benítez, y por supuesto a Rosaura Ruiz el acompañarnos. Agradecerle a Carlos Echevarría Cerur sus esfuerzos y la presencia de la ciudadana embajadora, que me imagino fue la responsable de que Carlos encontrara este espacio desde muy temprana edad, ¿no? Gracias por estar, Raquel. Y sobre todo muchas felicidades a todos los participantes. Ya escuchamos este proceso arduo de selección que llevaron a cabo. Son ustedes esos 30 participantes que han sido ampliamente y escudriñados a través de sus currículos y entrevistas para poder llegar a este momento. Felicitarlos, por supuesto, por haberse incorporado a esta escuela de verano. Escuela de verano que es la primera en Latinoamérica, la primera ASPP LATAM, ¿no? En Latinoamérica, que antecede a estas, creo que son 12 o 13 escuelas que se han hecho en Europa y un par de ellas en Australia. Entonces yo creo que es una experiencia que tenemos que aquilatar y procurar de alguna forma, Carlos, repetir periódicamente. El tema de que se hayan quedado tantos alumnos de licenciatura, pues por supuesto entusiasma, pero también preocupa. Necesitamos hacer muchas más de estas escuelas de programación, particularmente en forma avanzada. Y agradecerle a todo el cuerpo docente y a quienes han colaborado con el doctor Echevarría para la creación de esta escuela de verano, su presencia y a disposición emplear de aquí a este próximo sábado su tiempo en beneficio de nuestros alumnos del posgrado, tanto de maestría, doctorado, como entiendo postdoctorales, tanto de México como otros países de Latinoamérica. Así que muchas felicidades y muchísimas gracias. Y no me queda sino hacer la parte ortodoxa de esto, que es que siendo las 11:40, ¿a qué día estamos? Porque del día 26 de julio, queda pues inaugurada el ASPP en Latinoamérica. Muchas felicidades, muchísimas gracias y que por mi raza hable el espíritu.
Es así como damos por concluido este acto. A todas y todos ustedes, muchas gracias. Buenos días.
Gracias, jóvenes. Felicidades.
UNAM, la Universidad de la Nación.
Soy Freder Videgain, soy un hombre trans. Todo este sótano está completamente enterrado. Antes era Frida, ese era mi nombre, el que me otorgaron mis padres cuando nací. Tengo 39 años, soy profesor de la Facultad de Arquitectura y de la Facultad de Ingeniería desde hace 5 años. Y pues me gustaría ocupar estos espacios y la universidad para poder hablar y sensibilizar sobre el tema de la transexualidad. Cuando entré a la primaria y pues esta imposición del uniforme y que no cuadraba mi cabello corto con la falda, pues ahí me di cuenta pues de mucho rechazo, de que era una niña, que no podía ser un niño. Fue aquí, de hecho, en la universidad, ¿no? Decido pues empezar mi proceso de transición, que bueno, finalmente creo que eso lo he construido desde toda mi vida, porque pues desde chiquito, como comentaba, pues siempre sentí que yo debía haber sido un niño. Al decidir hacer el tratamiento de reemplazo hormonal, en el que ya llevo 10 meses, pues estoy consciente de que si bien nunca fui esta mujer femenina a la que fácilmente se le confundía con un hombre, o que no me dejaban entrar al baño de mujeres porque pues justo parecía un chico, sabía que ahora iba a ser más marcado, ¿no? Y, o sea, el paso como más importante, o el que le va a dar un cimiento muy sólido a mi transición social, a presentarme ya ante el resto del mundo como Freder Videgain, es definitivamente hacerlo en la universidad, ¿no? O sea, la universidad sí es ese espacio seguro, sí se ha trabajado mucho en eso. Me he sentido cobijado por mis colegas. Tomé un curso justo de disidencias sexuales, me sentí tan seguro en ese espacio que decidí abrir por primera vez que era un hombre trans.
is basically the sign here. So the commit I was reverting is this one. So this one here, it ends this line, and the new commit removes that line. Okay. So if it would be multiple lines, it would be accordingly. So git revert creates a new commit, which is at the top of the history. It adds a new commit which that's the opposite of the commit and revert. And this, if you don't remember anything else or you are confused, is the best way of undoing what we have done. The reason why it's a good idea is because now we have the history of what we have done. So we have the mistake and we have the step we take to prepare that mistake. And all of this is Git restored, and we can look at it in the future. So now, someone was talking about reset. So who said reset? Someone in the back. Okay. What does it do? I don't know. Are you accused? You know? I've just heard it. You heard it. And anyone else has ever used git reset to do anything? Typically, when you have a mess up and you start googling how to fix it, you will find things like git reset. That's why you heard about it. You will get a mistake and you want to fix it. So let's see what happens if I do git reset. No. So this is my file here. So this is, I am on top terminal now. Don't be confused with the switch terminals. So you see that the completion there is gone. Now let's try to make a better documentation. And I saved the file, and now if I say git status here, that's means that the file has been modified. Now at this point, if I say git reset, and I look at the file back here, the file didn't change. Status still modified. If I look at the notifications, that line has been done. So git reset doesn't do anything. So what happens if instead I say now, can someone explain what this git add was? What does it do? Come on, the people who just git regularly. What does git add do here?
Makes a file to be tracked by Git.
Yes, but and when the Git already knows about the file, then in that case, it does something else. It's basically it tells to Git if I now do a commit, it's going to commit these changes. The reason why this makes sense is that if we have many files and we do modify many of them at the same time, you may want to make a commit where you don't put all of these changes together in one commit. And when you say git add, you say add to the next commit only the changes to this particular file. Yeah. Later, when we do more of this stuff, we will use it more often. I mean, now it doesn't really make much difference. I could have done a commit directly. Yeah.
So you really, because we were already tracking that file before.
Yes.
So you're just building a commit when you
exactly. You build a commit. If I would now make a commit, I would create a commit with this change, with this line item.
With that change only.
Only with that change. Yes. So if I now say git reset, Now let's look at the file again. Here, didn't change, the line is still there, but look at its status now. Now it's red, and before it was green. And it says change not stage for commit. So what does git reset do in this case? Basically, before I was building a commit, and with git reset, I get away what I just added to that commit. So there's nothing to commit anymore. Yeah. So one could ask himself, okay, is this ever useful? Rarely. But it may be the case. You will rarely work like this. So that's why what I actually care about is another form of the git reset that you will find often in Kubernetes. It's called git reset hard. And now to use it, I will just first commit this change. Insist trying to document. Then show this. So now we have this commit, and it shows that I had the deadline. And now I want to get rid of that commit. We have done it once with git revert, which creates a new commit. But now, if I say git set, and then wait, first look at the log. So this is the sharp. We want to get rid of this. So I will tell that I want to go here. And now let's look at the file. So the file doesn't have the line anymore. The git log shows as a last commit, the last commit we had before. So effectively, we have get rid of that commit. The one I just done. It's not there anymore. So what does git reset hard do? It removes commit from the history. Actually, it's more complicated than that. But to understand what it does, maybe we can look at this in here. So if this was the commit that we get rid of, it basically puts us back here, and it deletes whatever it doesn't. Well, it is actually kept somewhere, but you cannot see it. So it's there. If you know the name, the sharp of the commit, you can get it back. But you probably don't know that because it's a very long string. In the git log, you don't see it.
So is it the reset function is it like removing just that commit and keeping the others, or if you remove the then that means that you remove the others?
No, it will try to remove only that commit. Which means, so if I like, let's say we are here and then I do git reset. If I do git reset here, it will move here and get rid of everything. Yes.
But what if you modify something there and then in the next commit you modify this line that you
yeah.
So then you have like
yes. So what you say is now we have this file, the line is down, right? And now you want me to do something here on this line again. Right?
Yeah, but I mean before you remove it.
Before I move it. Okay, well then we can recreate the same mess again. Now this line. So create it, we commit. So now we have a commit with that line. And now what you say is what?
You change it.
I change the line.
Yeah.
Yes.
Yes, and then you commit again.
And then I commit again.
and you want to burn this comment.
So now, what we have two commits that change the same line. This commit here and this commit here. And you say we want to go back to where we didn't do, like we want to go back here. Or what do we want to, what is it that?
And if you will remove all the next commits, the new part of the line will be also. Yes.
So what you say is, if I now do git reset and I go here, you want to see what happens, right? Is it right? So we say git reset. We can let's do it without hard turn, but so it gets more complicated and confusing. Now, if I look git log, I am back to the original from which we started. But now, if I look at the file, the line is still there. And if I say git status, it tells me that the file has been modified. So what happens? If I don't say hard, it will get rid of the commits we have done, but it will not touch the file on this. Why would I want to do that? Well, in one case, maybe I have, like these commits are all useless for clean section. Like I've done this commit by mistake or because I thought that it would be useful, but actually it's not. So if I don't want to have all this history of the Git full of commits that have a meaning, I could do that. And I'm not losing anything. Right? Because the changes are still here. Now I can still modify this file, for example, by getting rid of this stupid line. Sorry. And now Git should notice that there's nothing to do. I'm trying to, oh, I created an interesting file now. Okay, I don't know how that happened. I created a strange file. So, and now I'm back to this commit. Right? I modify now, I edit the file, I remove the line, and then it says, okay, now this looks like the version we have imposed. Okay, this is complicated. In the repo, I explain a bit better what the stuff is, and there are some, there's a PDF file. So here, go back. This here, Git command visualization, is a PDF file where all of these commands are explained in some graphical representations. Yeah, so here it will explain these things. So you can look at that later if you really start using these commands to see what they do. There is another command that I want to talk to you about to fix problems, and it is called git restore. So we have revert, reset, and restore. We have heard of git restore. Git restore is much nicer than all of those facilities now, because I don't need to think. I can do some mess here, and then so now Git notices Git modify. If I say git restore, it will just, and here see that behind. I open it again, and everything is gone. So git restore, well, I can get the same effect using git reset, but with git restore, what it does, it takes an argument, which is a file, and it tells, get rid of anything you have in the file and put it back in the last commit.
It only applies for one file at a time?
Yeah. And this is the good thing, because Git rebase and Git reset applies to the whole repo. In our case, it's the same because we have only one file, but we have several files. With this, you can target one single file and say, this one I messed it up, bring it back.
And we bring it to the last commit.
To the last commit, support have. The last commit is in the current branch. Yeah, good. You were talking about Git checkout. Someone was talking about Git checkout before. What? Yes. Yeah. What does it do?
Well, I usually use it to change branches.
Yes.
And sometimes to the same as it restore. So you have some changes.
Yes.
Let's
do it. Let's see what happens. So I now have some changes. This line. Now here, this is the moment you should use checkout.
No, usually when I do the pull.
Yeah.
So sometimes I get a conflict.
Yes.
So I just go to check out the file, and that's sort of gets rid of the change that I did.
Yes.
And allows you to put the large.
So basically, use checkout as we just used restore.
Something like that.
Well, then it's better if you use restore. It is better if you use restore.
Yeah, that's why I'm learning today.
But because checkout is much more powerful than, well, for example, let's first of all get rid of the change now. And then get log, and then we could say git checkout this. Checkout, as the name seems to suggest, allows us to go back in history and put the files on disk, the status they were when that commit was done. So if I now look at my file here, this is the way it looks before we move the get credential in that. Okay. And if you look at here, its status tells us something interesting. Had detected. Right here is everything is red. There are strange numbers there. This is a signal that something is right. If you could git log, see that we only have that file there. The problem is that I'm not on the branch main anymore. I'm somewhere else. Actually, this state is called detached head because I put my status on disk on some random commit, which is not a branch because the branch is main. So I now can look at the file back 10, but I cannot work on it because now I cannot create a commit here. Like imagine I now try to change this file again. This status. Now I'm going to say this. Oh, yes. You never know. Oh, it works. Okay. What? I doesn't know it works. I can. Well, I can create a new commit, so I can create commits here. But interesting enough, maybe this is the moment to use something like that. Look, I have here the font is too small, and unfortunately I cannot change the font. But look at the TV. Look at this. This is our branch main with all our commits until the revert commit. And this is how we're now detached head, which has a different history, independent of the other. So basically, we created a kind of a new branch which is not connected with the original branch. So it's a total mess, right? Because now we can't actually use this for anything. So how do I go? I will get rid of all of this and go back to my name. Any idea? Yes. Thanks. No.
Check minus -b and the name. Check out -b main.
Good. This is the old way. We said checkout. We want to avoid that command. There's one. This is much nice. It's called switch. And now you're back to me. So git log. Everything is there, and the file is again the one to start. Yeah. So git switch changes branch. If you want to change the branch, so git switch is the name of the branch. Those of you who learned Git, let's say 3-4 hours, 4 years ago, learn to do that with git checkout -1, but don't do it anymore. Do it switch so that you stop using checkout, which is a dangerous command switch.
Switch followed by the
branch name.
Branch name.
Yeah. So this is what we did not git switch. So now I published my, or let's another interesting thing that I want you to see before I go is that in our log we see that this is our last commit, the one where we did the work, the documentation item, and head is pointing to main. And then for the other commit, it tells me that this is origin main. So the main branch on origin, which is our is still at this commit. Right? So I need, if I want to publish my results, and now if I look at Git log again, now you will see that the last commit is both by main branch local and local. So now, Jacob, this, let's say a fellow scientist, starts using my values credential function and wants to help. Right? So we have a GitHub repo, which is this. How would he go about doing it? Well, what do you do when you find something useful in GitHub? Well, you first clone the repo, right? And you use it. So now we will see. Yes, it is.
All right. Can you take over? All right,
And let's you have to type my name reverse. That's the last trick.
All right. Okay, so I guess I go to GitHub. I need to type a name in reverse.
Yes, or you copy it from here.
Is that complicated? Right. Now,
repositories. And that's one.
This one?
Yes.
That's one.
So now you will start telling. So what does Jacob has to do now? You said clone. Yeah, clone is not enough. Like really, from here, from GitHub, how do we get from GitHub to Jacob having the code on his left? Oh, someone talks about fork. No, we don't have it. Let's work with clone number first. Yes.
Then we go to the terminal, and I go to terminal.
Yes. Good. Let's think this is interesting.
Right. Yeah. Is it something?
So now he has everything, right? And now he wants to do, what do you want to do? Well, I think what would be useful, I think, is to store the database. We create this database of passwords because at the moment we don't have any. Okay, what do I do? But the terminal doesn't fit the and we need better? Can you read it? So I guess I will be working on the on file. As you can see, I'm using a different element. That's a clear example. Okay, hopefully you can resize the font. No, the font is big enough. No, it's big enough. Okay. It's too big now. Okay. So I need to create a database somewhere. Well, so we want to have a file right to be put on this. What kind of format would you use to Python things on this? ASCII, yeah, well, yes. And how do you format it?
You can use a CSV file.
You could use a CSV file.
Okay, just a JSON file.
Everyone knows what JSON is? Ever heard of it?
Dictionary on campus?
Looks similar, yes. Anyway, it's a text. It's a text format. It's a text format to store things, numbers, lists. It doesn't come with context objects, with classes. That's why the class idea wasn't so good, because then we lose this ability of just working with text frames. But have you ever heard of people? That's it. So we're not talking about that. It's actually the standard Python way of serializing its code. So when you write stuff on this, it's called serialized options. And the default way of doing it in Python is a model called people. But this is not a good idea to use. First of all, the default is not text, but it's binary. So you cannot look at it. The other problem is that it's Python version dependent. So if you people a file today and you open it in 2 years, Python may not work. That's why if you have just objects that are easy enough, that contain only numbers or strings, then it's better to use a format which is independent of the Python version. And if you write a JSON, for example, you can read in any other programming language. CSV would be another option. How do you write JSON files in Python? Yeah, but open function, yes. So to open files. Yeah, but how do you write JSON? You know, there's a JSON. JSON.
So I guess I import the JSON.
Yes.
Thanks.
Okay. So Jakob doesn't.
But what do I write? How do I start? So you have to write use one of those functions, maybe the gravity WD. Yeah, and you need to get the user and the password as parameters of your function. That's what you want to store. So the parameters for your function will be the username and the password.
Okay, are we defining? That doesn't matter. We will change it.
Okay, and maybe, well, I don't know if we are going to reuse a file, so you need to know the path or the file name or so. So you could also get that as a parameter.
Okay, for now, let's just try to store a single user that
say 95
in some function.
Right, so we need to build up a dictionary. It's easier, so you can with the key user and the username and not really, because you need to store both the username and the password. So it could be the key, the username, the value with the user, and we will have another key called password.
Yeah, right? No, but why not? I mean, this is enough.
And that's gonna look like this, right? Well, that's what it was. No. Exit it, I get the username. So this should be sufficient. Store now over there, we have the key and we have. Well, it's all right, yeah, and then you check if the username is in the keys.
Yeah, so.
No, I mean, so in that way you can, because I'm thinking you need to somehow check if the username is in the. So I said we're gonna check later. For now, let's just have that's right. Yes, right. Okay. So we already have our. So now we have our database, when you have the entry of the database. Now you have to dump it in the file. So you need to define a file name or so. Okay, we have file name.
.json.
All right. Now we have everything. Okay, how do I store this now? You said something about open.
Yeah,
what about open? What do I do? Have you seen this construct? Yeah. Oh, yeah. We open binding for not close, for avoid the close symbol. Something like this, right? Yeah. I guess using the context manager here. Basically, I mean, I don't know what I'm going to talk about. But you could also do it. You could also do something like this. Then do something with that, and then you need to close. Otherwise, it's not the file. And if you use the context manager, or you create a new context, let's just assume this is and then automatically, once you exit the context, so I can do something with the file here, and if I exit, right, and now we need to use the JSON library to write. Done. What weird?
This I never know. You like one knows is the what is the order of the argument?
Yes. What is
What and when where? For me, it would be more logic that yeah.
When the script says this,
Yeah.
you know, something. Okay. This is it. This is all we need to do. Yeah. Doesn't work. And we have all your passwords.
ABC one.
Yeah.
Wait, no, look at the other. Look at the other.
Let's debug this together.
Yeah.
That's like pair programming. What's the problem? Any ideas? Would you come back to click up?
Which line did we get the error? No, this is the first interesting thing. So line 21, when it does right, then we read the JSON down, and then JSON is complaining about something.
That's line 14. Yeah. So you're not using the context. So you're using the file name, which is
So what did we learn from this? Use very express variable.
Yeah.
Right, let's try this again. No error. That's good. So we have a new file. Our database JSON file.
And Tiziano mentioned that it's now stored in a way that you can easily read it, so bend it. Let's look at it from the Great. Ready. We have created a new database for the single user.
Yes, can you make a commit and give it to me?
This is an actual commit?
Yes.
What do I do?
Give commit.
Well, let's see first game statements to see what you change. So we modify the Python, and so there that.
So it doesn't know anything about the database, right? And ideally, we don't want to commit this, right? Because it contains the passwords. So this we should remove, and then this is what we want. So this is one of the cases where, for example, it's a good idea to commit add manually, because then you explicitly say what you want to commit, and by mistake you don't commit stuff that you don't want. So this is very important. So, well, I think the application doesn't go to use by the way, you probably noticed that in your laptop you don't get VR when you do this. You get a simplified editor. No, but it's not the default, so I hope.
The default when you're doing the commit stuff.
Okay. It's an editor that tells you what to do. You have something called micro or nano.
Micro, but currently it's not so super.
Then it was featured.
It's less obvious than
Maybe well, we can fix it anyway. Anyway, the thing is, don't be tempted, don't use the iron unless you know what you're doing. Most use the Google search for the eye is out by accident. So that is not the problem. But try to avoid finishing the situation use them.
Okay, but if you get stuck in the eye, right and exit them. So that's what it's called. Okay, now created the new commit.
And now, how does he share his work with you? Push it. Where? Push it. Okay, push.
First you have create your.
Yeah, do it.
This? Absolutely not.
So
what do we go now?
We use our SSH.
Is sounds good. Let's look at my remote.
So you see, first problem when you clone by default, it uses this HTTPS address, which while you work with HTTPS authentication, which, by the way, even if he knew his password, he doesn't. But even if he knew, it wouldn't work because now they have this two-factor authentication thing, and you will get an error later saying, "Oh, I cannot." So if he now wants to push, he needs to set up the SSH thing. Do you ever set it up automatically? Can you do it to set up SSH? Yeah. Okay. How to change the root?
So I want to change this address now because it's using the HTTPS. So username password authentication, I want to change to SSH.
So git remote -h. And then you see that you can change the URL, set URL.
But this is just changing the.
Related to us.
No, you're changing the word.
So he's changing the URL of the remote to use the SSH and Git instead of HTTPS.
Right. So if we now compare the output of Git remote of -v, you can see that up here. That's this HTTPS prefix. And now down here. That's the HTTPS.
So now you can
Very doesn't trust become.
You need to add the journal as a collaborator.
So what we see here is that we start having the first problems, right? So if he wants to share his work with me, now he has no way of doing it because he doesn't have right access to my repo. So one option would be now I invite him to join my repo as a collaborator, and then he would have right access. And now, in which situation is this a good idea?
When we know each other.
When you know each other, right? So because we know,
not just
we know each other. Screen. So let's add because this is a scenario that you have quite often, right? So you are working with someone and then you want to work on the same way. So no need to fork here, you just need to add the permissions. So, and I think, are you doing here, collaborators, oh shit. This time, so right, and then to deactivate, no, what is it? I invite him. And he has to accept my invitation. You accept it by going to somewhere. Now wait. Okay. You got an email probably with the invitation. Wait a second. This is with GitHub. This is with GitHub. Yeah.
When you switch to a repo on a recipe server, the other person has access to the credentials to read the files.
Yeah, well, it depends what system the university is using. If they use something similar to this, like GitLab, then it would be similar to this. You would have to log in into the interface and add the person as a collaborator. If you are working with Git repos that are just stored as files somewhere in a shared remote, could be NFS, I don't know, file system, remote file system, then the permissions need to be right. Needs to be the right group and so on and so forth. And this typically only the system can do.
So this will
yeah, GitHub is taking care of this thing underneath.
So now when I open the repository again, and I can see now here that Tiziano has invited me to collaborate.
Yeah. To accept.
Now it's basically tells me now I have projects.
Okay, so now we put now the push may work. Can you try? Here is good work. So now there's a problem with this setup, and then we will create it now immediately. So what is the problem? The problem is that so Jakob has done something, and in the meantime, I want to write the function to add the user to the database. I guess that I need user, password database, and then if user not in password database, so database user password, then right? I have a basic implementation of how to add a new user to the database. And now I want, because it's a very nice thing here, the status I want to commit. Now Jakub tells me, hey, I've done something. Why don't you? So what am I doing here? The first time we use full. All right. Let's first understand. I've done this work and I learned that every time I do something useful, I push it. Well, now there's a lot of bad things happening, so it's rejected, fail to push. And then if you, when you get this long error messages, it's always worth to read them. Because they basically tell you almost everything you need to know. So updates were rejected because the remote context work that you do not have local unity. This usually goes blah, 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 blah. So what's happening now? There is a new commit that did. I did another commit. So now if I push, then Git doesn't know how to do these two things. Both commits are born from the same commit. So that doesn't work. How do I fix it? I'm sure you have had this already many times. So how do I fix this situation? Pull. Merge. Yeah, pull, merge. What is it? So we can try to pull. If I say it's pull, and pull is like push, you say pull from where, from origin, what made this. And then it tells me not possible to fast forward a board. What does that mean? This is an error message that doesn't, it's not so beautiful. Anyway, it says fast forward means that Git is able to just take remote commits and attach them on top of your commits locally and everything is fine. This is fast forwarding. Fast forwarding doesn't work. So aborting means nothing happened. If I look at my file, so here, let's close the window. The file is still the same, no change. And the Git status is still the same. So I still don't see his changes. So pull doesn't work. Someone else said, what did he say? Fetch. Merge? Yeah, but merge what? It merge and then? Right. So git merge what? Main? Git merge main and then? So you're that I am on main and I tell Git to merge main onto main. I guess Git will do it and say, already up to the left. These commits. So how do I do it? You were talking about fetch. What is fetch actually? So fetch takes the remote commits, put them in the database, in the Git database, but doesn't touch my files on this and doesn't touch my main branch. So if I say git fetch origin is important, from where you want to fetch. It did. We don't see anything here because we have done pull before, and pull underneath does git fetch. So basically, this git fetch now doesn't do anything. But if I wouldn't have tried pull before, now it would show basically all of this except from this. So, but what is interesting here is that it says that there is a remote main is locally called origin main. I have that branch locally. Now, so I can say git switch origin main. No. Wait. So, that's I guess it work. Thought it should work. Does it? Does it status? Now it says it's fine. I thought I can change to your branch. Yes. Just one problem. Yeah, that doesn't work. Wait, wait. No. I don't like that it must work. So, yes. So this is the way it works. So let's do it properly. Let's clean up this. So, sorry. I want to clean up this clean thing. So git status, git branch, and I have these branches here. Now I say git switch. When I say this, it complains, telling me that if I want to go there, I have to use the detach. Yes. Now look, I have now Jakob commits here locally. So let's go back to main. And now we merge origin main on. So I looked at Jakob commit for the word here. Right. By switching to the remote branch, this detach is needed because now I understand why it doesn't work, because I've never worked with, if I would have started with clone, this wouldn't be needed. But forget about it, we don't care. I followed the error message and then I had a way of looking at this commit. I liked it. So now I can try to put our two commits together by merging the remote branch to my branch locally. So if I do it, it creates a merge commit. Save it. Now I have this merge commit with Jakob's commits here. We look at how it looks. I know that the font is little, but we only actually care about the lines. You see that there we have our initial commits. Then this branch was the branch that, well, the remote main branch, and then this is my commit, and then we have put both of them together. So now, if I look at the file, I would expect the file to look nice. And now, yes, so we have both of this. So you see that this was a bit annoying to do this work, right? Because now I have to do this fetch, I have to look at the commits, I have to merge manually, and then if you have ever tried to merge things, you also know that sometimes merge doesn't work. So if it would have worked on the same lines, then merge conflicts. So what is a way, if you want to work with this one repo, that we can coordinate without having to do all of this mess all the time? You have an idea?
Doing a branch and we pull requests or so.
Yeah, that's already so much, but creating branches. So what we could do is we could work on parallel branches. Instead of working on main, I can work on branch Tiziano too, right? We can work on branch Jakob doing this thing. And then we can merge manually whenever we want to merge. Right? So if you want to look at the schematics of this is the way it looks. So this was the one we were on actually. So this was the situation when I was still working alone, right? My laptop, GitHub with origin, and then I just push here. Now when I have some lens here, this is the way it looks. Seems more complicated, but actually it's not. Look, we have our laptop, I'm X, like before. I'm pushing to my origin, and here we have Jakob, Y, who is also have the same history, right? And he has done clone once, we do it only once, right? And then we both work, we push and pull. Ideally, to avoid merge conflicts, we create branches. This is the first time where we care about these green lines in the schematics. And so I create a branch and work with my branch, he creates his own branch. And then when we want to share work, we push these branches to origin so that we can look at the branches. So let's do it. You have this stuff on the repo, right? So when sometimes you clone the repo, you do that with this. Okay, so did you push your favor? Well, that's good. Let's do it. So I want to get this. No, I want to get Tiziano's work. So excuse me. Why not together? Different origin. Main. Nothing happens. Different origin main. Nothing happens. Look at the file. Maybe something. Well, the doc. Maybe something changed. So why is my work not there? Because I forgot to do something important, right? So I took these changes on my laptop. I merged with my changes. Now I have a good version, but then everything is still on my laptop. So I have to go. You never use it. You're not allowed to use the book without that. Already up to date. I need to push. So can you give me the? No, they have to see. They have to see. So I'm to collaborate. So the thing is now my main is good because my main is good, right? My main is the one that has the worst stuff. So I have to push it. And what do I push again? Git push. Origin main. And now it is released. I don't need to commit. Oh, that's an important point. I didn't need to commit, right? Because when I do git merge creates a merge commit. So the commit has happened in the background. It's what git merge does. It's yes, this is already a commit. So I'm good. The changes that Tiziano is pushing. Looks good. When I look at the log, yes, it looks identical to the one on Tiziano's machine. So now, how does Jakob goes about now creating a branch? How do you create a branch? Not the way of 5 years ago, but the new way. Which is big branch. So big branch with a name, and then by default we just put our names. You may have more interesting names at some point. Okay. And then, if you want to work on that, git switch. Yeah.
I feel this ridiculous.
Yeah.
Now it just
But you previously weren't able to.
Yes, why? Because I had created the commit before pulling these changes. So when I said git pull, git could actually take changes because his commit and my commit were both derived from the same base commit. So we have two incompatible histories. So what I have done is I have, instead of merging, I first took his change. I mean, instead of pulling, I had first took his changes locally, and then I said git merged. So Git created a new commit. So basically, Git created his changes were on temporary branch, and then the merge put them together, created a new commit where both commits are now together. So this works. He can do now git pull without anything because he didn't have any local commits, any new local commits.
Yeah. So before it was speaking about fast forwarding, this was not possible fast forward.
Yes.
So you just take whatever happened remotely, add it to your system. So if you did the git pull before any commit you did locally, we didn't have to make the merge.
Exactly.
It's a very safe way of doing it, but it's maybe not an ideal way of doing it, right? Because then you're serializing work. So first you pull, then you tell everyone else to stop working, and you work, then you push, and then you allow the others to work.
So that doesn't actually work in practice, right? So the whole thing is either we sit in the same office and I say don't commit anything, I do it before you, and then which defeats the whole idea of this kit. So basically, you work in branches because then you don't have all of these issues. So now we can implement what we need fast.
Fast. All right. Yes. What do we need? We need to read the database. I guess we use what is that? What is that? No, sorry. Just did nothing. Okay. So I want to read the data.
No, load. And
yeah.
Yes. And then the only thing is, okay, can you test it? Value. But you're not using it, so it's
yeah. Okay. I guess I should probably load it somewhere here. Maybe before the user and password. Yeah, first line. This.
Put it as a first line.
Yeah, I can put it up here. You know what I do with this?
No, you could print it here, just print it up with this. And then we will maybe learn how to do better than print if we want to. So no, it is really read, it is there, it's fine. So the only thing that actually we are missing is how do we add new users here. So can you now use the function ID already? Add new users. That don't work, right?
No, why not? No. They will be duplicate the user and password.
Let's see. Let's see. Try. This is empirical science, so you have to try it. Well, this is, of course, if you type always my name, can you add user, can you all user?
But I don't give it my last one.
But
something happening. Let's go back to the point.
Look at the code. Well, look at the bright, because
You can add in the right function in open. You can add an A that is the to a base.
That's not going to work. No, because then you're not respecting the GC. There's a problem here. He is basically overriding the password database. It's not a user. You load the one that exists and modify it. You don't overwrite it every time.
But I think it's even more trivial than this because I never called it right. Okay, so I want to write a new bus.
But your function doesn't take out of carrier.
Yeah. And then I need to let my function, of course, to actually set this dictionary that contains the combination of this and password. I don't want to do this. So now I'm actually getting the database, which may have been updated with the user, and writing that one. It looks skeptical because I made a stupid mistake, or it's not obvious. Okay, so let's just go through the code down here. So I'm reading the database that exists on this, right? Then I'm asking for the username and password. Then I add a user to the database. But that way, I think we have an issue with the naming, right? So the database is the dictionary that exists currently in memory. It's not the thing that's written in this. Dictionary. Okay, so I know this dictionary by reading from the database. Then I ask for the password. I update the dictionary. And here I now say, okay, write this dictionary to this, which is updating the database that is stored. Okay? Now let's go back to this is not right. Commit, I guess.
Nice.
What do I do now?
And now, wait, and now what? You push what? You see, that's why I want to. No, it push what? It push. Yeah. Where to origin? Not to main weight. So git push. The first argument is where you push, on which remote. We have only one, so it's origin. And then what to push. And now not main, because you can do push main. Push origin. Good. Nothing happens because main can change. So you actually want to push this branch. That's right. So git push origin. So you see why it's important to add the implicit questions, because now we can work with branches. So so now how do I get these changes?
Pulling his branch? By pulling his branch?
By pulling his branch, yes, and now if I pull the branch, so what we said that pull means fetch and merge. Do I really want to merge this stuff on my main without doing it? No. So what do I do? I can fetch this branch first, right? So we fetch origin, and then it will tell me that there is a new branch. And now if the magic works, I I can just say git switch Jakob. And then because the name now matches the remote branch, it will then tell me that the local branch Jakob is now tracking the origin Jakob branch, which is the remote one. And then the branch didn't exist until now, so it tells me switch to a new branch. So on this local branch, now I have the stuff is done, the database. So, and now assume we looked at it and we like it. The problem is that if I try to use it, you will see that this breaks. Why does it break? Because in our code we never create that file. So can you? So how do I work about this now? What should I do? Should I fix it here on the Jakob branch? I could, but it doesn't seem like a good idea, right? Because then we still have the problem. So what I actually can do is that I can now out of, so this is the local branch Jakob. I will start a new branch and now I call it git branch and then let's give it a name that makes sense. Let's call it this DB, no? This database problem. We want to fix it. And we switch to this branch. Now, all of this is just a dance of names. I'm still having the stuff here is done. Now I'm on a different branch. It's called this DB. Here now I can fix things without interacting with what, without disturbing what it will do later. So thing, and then let's. So how do we fix it? Here, the error was, now let's create the error again. Where is it here? Yeah, so the error is here, is on the first line when we read here, line 25, so which is this line. Yeah, line 25, this one. So basically in the read database, where we open here, we just have to check that it exists, right? So there are many ways of doing it. One way we could do is to do this, right? This, except error. What do we do here? Create it. We create names dictionary, right? So if there's nothing, it means, I mean, if the file is not there, I don't have any user in now. Everyone agrees that this is a good solution? Yeah? And the try accept is more or less understandable. Everyone knows what it means? Yeah. Well, don't go, it's interesting because this question is quite interesting. Because those who say yes, of course, no, right? So if I say everyone knows, it's a stupid question. No one can actually answer because you don't know what the others. Sorry, I'm a bit. So does someone don't no? Someone is there anyone that doesn't know what I accept this? This is not a bad question because you don't want to outuse. So let's.
You can speak to us on the way.
Exactly. So let's create this again. And now I hope I have the database. Yes, it's there. Let's create also Jakob, and he uses most of the password. So now we have the thing. Git status. So there are two things now that I would like to get rid of. First of all, well, let's commit what I have done. So fix DB not existing. And there is a thing that I don't like. It's the fact that now, because of this file is there, every time I say git status, I see this red thing. And I have to learn that red things are bad and I want to get rid of them. So I don't want to have a situation where I always see this red line. How do I get rid of that? How do I tell Git, don't ignore forever that file database JSON? I don't want to. I have to create a file which is called .gitignore, where I put the name of the file I want to ignore. And now good look at git status. Git status now tells me, well, I don't know what to do with gitignore. But all of a sudden the other files disappeared, right? So we have to add gitignore.
What more than more? Probably something that you want to share also with the collaborator.
But yeah, that's what I was going to ask. So would it be a good idea to have a shared gitignore?
Definitely. Because what makes sense for you to ignore should not. That's not the case.
But what if you have a bunch of files in your local, and you start ignoring those files and then you share the local more to some other guy who hasn't really about that stuff?
I mean, so if it's, for example, if the editor creates temporary files and you can use wildcards to ignore all of those, which add a couple of lines to the gitignore and a certain setting you can share with them.
But also most of the time, at least from my side, like every time I add or I'm like before commit, I always run git status. Because I track all my files manually and I add them manually because each commit should be with intention, right? You're committing for a reason, like I'm especially adding these files to this. So when you git status, you see that there's a file missing. And hopefully that's what you do. Obviously, that's not always the case, but it's nice.
So how do I go about it now? Now I have a branch. What do I do now? You should know. So how do I share the work with Jakob again?
When you have to push from the branch you're solving the issue to main.
To main. Well, we have many things. There's one thing. Actually, this now is working. So it's a working version. We could decide, oh, this is how I want to make a repeat. Okay, so we call it, oh, this is good to be managed. So I could merge to main.
Because maybe Jacob is working on something else.
Yes. So one thing I could do if I want Jacob to review my changes, I could push this. By saying good origin, this database, this will create a new repo remotely, a new branch remotely. You will be able to do that. Now let's say I've done it, just look at it, and we agree it's a good idea. We want to have it on main. How do I get it on main? Switch. But if I say, okay, let's say, let me close the file here. So git switch main. Now I look at the file, and it's almost empty. So switch is definitely not enough. I am on the branch main, and how do I get started that I am on branch this on main? Merge. So I say git, and not here, git merge this BB. So, and when you use this form, which I suggest always to use, you switch to the branch you want to merge into. Okay, so the new stuff is on the argument merge. So this will take branch this DB and merge it on branch main. So it merges on the branch I am at the moment. That's why it's important when you use Git, if you work with the shell, which may not be the case, because the graphical user interface is different, but if you use the shell, it's good to have the branch in the prompt, so that you always see in which branch you are. If I wouldn't have the prompt, how can I check which branch I'm in? Git status is one way, yes, because it tells me at the beginning here on branch main. Another way is git branch. It lists all the branch and the one I'm in is with a star. So git merge is, now this has been merged. So if I go back here and open the file is the one with all the stuff. See here. And it is working. So let's test. Yeah, nothing happens.
I in the last question.
Yes.
Why do you merge with main and not with branch?
Because if I merge with this branch, and he's working on his branch, again, I have the same problem we had before, right? That I create commits he doesn't know about, he creates other commits, and then when he tries to pull or to push, there are going to be errors because the commits they're not compatible with each other. That's why we always work on branches, right? So I merge on main now because we have a discussion and we agree, oh, this stuff is good. We want to have it public for everyone, and then everyone assumes main, the main branch where the stuff is supposed to be that works. Right? Yeah. So, if we look at the G again, I'm sorry for the fact that this is so little, but so what we see here, the interesting thing, look at the TV because so this was the Jacob branch, which now is on main because I merged. But why don't I see the suite when I want to see them? Segmentation code. So EG is broken. That's why it doesn't recognize. Yes. This is less nice. No, but it's. I was expecting. Is it what we expect? Yes. Right. So yes. So we don't see any branching because main. We just added new commits to main. There was no need of merging other commits. So basically just put on top. That's why this line just added the two commits on top. You don't see anything. In case you would have done something on main in the meantime, then there would be a little loop like in that below. I was confused because I was expecting a loop and didn't see it. Doesn't matter. So now I've done all the stuff on main again. This is only on my laptop. So how do I put this into the internet? What? Very good. Now, so now you heard it so often that git push or unit. So, and this is the way you work with a collaborator. Maybe let's say we are 2, 3, 4 at most. You can still coordinate. You see that we still need to talk to each other, right? We need to look at the branches, decide, oh, this is not good, I merge it and push it. Now if it wants to work on something new, you shouldn't work on this branch Jacob. You should put this branch Jacob up to date with main, right? If he wants to do anything because he wants to work on top of what we have done. Can you do it? Right. Did it work? Yes. We had the choir. Okay. So how can Jacob get the stuff like that? No. Before this pulling is very good. First we make. And then what? Origin main. So now a couple of suggestions how to work with this in general. You never work on main, you just see it, right? So you always work on branch. The branch is either a branch with your name if you do some long-term things, but ideally the branch is connected to a particular thing you're doing. For example, what we don't have now that Jacob could do is to implement something where we check if the password is correct. Because at the moment, our program is starting to distribute. It gets credentials and overwrite to the database. It never checks if the password is correct. So this is still missing. If you want to do it, instead of working on Jacob, you should pick a branch. Let's call it authenticate. And on that branch, you would then implement the action. Right? So everyone works in different branches. And then we agree that the stuff we've done is good enough. We merge on main, push it on GitHub, and then our official version is online. Yes.
He merged when he put the name, but what happens with the branch? Is also updated?
The local branch, whether we do it in chat.
Yeah.
So no, right? It's not updated. That branch, and now if he wants to keep on working on this branch, what should he do?
He could directly merge the pool in the Jacob branch. Right?
No, why not? So we have already a local copy of the main remote branch. So we just set up to merge, right? So you can merge local main onto the local Jacob. Wait, so we are on Jacob, right? And we merge main onto Jacob. And this should work without problems because we have worked cleanly. So here,
nothing has changed in that branch. You could just add the commit main.
So you can see git log now. Yes. Okay, so how do we scale this bit? As you see, if you sit in the same office with people or you have strict connections, this is bit by bit, right? You have to add the person to the repo as collaborators, and then you can work more or less. Everyone works with branches and so on and so forth. And I don't expect too much problems with it. Now imagine, of course, imagine that now we are in the same group. We will not have only one repo, we will have several different projects. So the only difference, if you have several projects, you get different repos. But on each repo, you work with the same scheme. So one thing I would advise against, even if I've seen it in the market, is to have one single repo for all the projects. This happens, but it's a very bad idea. Because then, it's difficult because commits make me not connected. Like committing one project, committing another project, but then when it goes to pull or merge, the fast forward is not possible because there are commits that have been done in the meantime. But these fast forward errors do not actually have anything to do with my project or other project, and so on and so forth. So no, every little project has its own repos. Repos are quite cheap. In terms of storage space, in terms of GitHub allows infinite code also, so there's no reason not to create separate repos. Yeah, so because we have 15 minutes, right? So we can start this talking about that, and then after lunch we do it for you. Now, there is a situation where this is not enough. And the situation is, for example, if you start collaborating with more than 3 or 4 people, because imagine if you have 30, 40, you now start adding people the permissions to the repo, and then they leave the lab, and then you have to remove the permission. Then you start adding a lot of overhead first. Then everyone has access to main, right? Everyone can mess up. You have a new bachelor student coming in. They don't really know well what they do, but they overestimate what they know, and then they do a mess with it, and then you have to clean it up, right? So this only works if everyone is more or less on the same level, and the level of trust is higher in you. Now imagine the situation of NumPy. NumPy is also developed in GitHub. There is a repo on GitHub, but there are like thousands of people that fix bugs or have proposal for improvement on the documentation or in the code. And if the NumPy developers would have to have the same level of trust to everyone that must collaborate, it wouldn't actually scale. So we need a system where we don't need to trust people that want to collaborate. And this is then what we're going to do after lunch. all the way through. And it is the system that I would suggest you use during all the language. So even if you did not need it because you trust each other basically here, it's still good to know how to do it in that. This is where we are going to have 4 pull requests. Actually we can do 4 now and then. So let's see. I just to confuse you a bit. I show you the screen. So this is overcoming your fears is part of the process. Okay. So this is the full-blown open source development scheme. We recognize the paths that we have already, so laptop, main, working tree, branches with proper names, right? Then we have origin, where we have our repo for the internet. Now, until now, everyone wanted to collaborate, needed to have access to this thing. So we don't want that anymore, because we don't trust others. So we need another repo, which we will call upstream. This is going to be the repo where that is the one where people that want to use our software get the software from. It's upstream. So it's the boss, the one that tells what our stuff is supposed to be. And then, if you want to collaborate, you will fork this repo, which we create origin on GitHub. You will load on your laptop, so that you have a copy of upstream on your laptop. You work on your laptop, you push changes on your origin, like we are doing now. But the changes now stay here. You don't have right access to upstream. This is only an alpha developers app. So what you can do is, once your changes are here, you can issue a so-called pull request, which will create a notification for the developers of NumPy that know, hey, X has a bug fix and wants this bug fix to be merged. And then they will be able to look at it and merge it without me having to do anything. So they are the only one that have right access here. With this pull request, I just made them aware of the fact that I have a proposal of change. It's a pull request. Now we know what pull means, right? So we are requesting that they pull our stuff on there. We never push. So we only push to our, but we cannot pull here because we don't have access. And now this is me. And then we have laptop Y. This may be Jacob. This may be someone else. So now we can have thousands of laptops around here with thousands of different origins. And the NumPy developer don't have to care about taking care of permissions or anything else, right? They will get just stream or pull requests. I'm not sure if it is, you say all right because you understand it or because
it's very good with the next part.
So, and I think this is the moment where we could start working with the proper repo, not the one I created now just to show, but with this one here. So this is the main repo, and then I want to fork it. So I go to fork. And and if you look at here, now so we have the main repo Look at the URL. So this is on ASPP LATAM. And my fork now lives on here on my account. Okay, so this is a copy of this repo on my account, and I have all of the. So my first fork, you do it only once. And important to remember, this is there's no other connection between my repo and upstream. It's only once. So there's no automatic updates, there's nothing. So now that I have this, I can clone it locally so I can work with it. So I go here and I say, git clone with this. And yes. Here and I want to share with whoever owns this repo. In this case, it's me, but let's imagine this is someone else. But Jacob also has. I'm missing. Jacob also has right access to upstream. So we will not play the game where he is boss, doesn't know me, doesn't trust me. I want to add whatever we have done until now to a special branch so you can look at it and decide if you like it. So I create a branch called it authentication. I will copy the file, development number here. Oh, I have a new file, right? Now, before I commit this, I need to create a branch, right? I created the branch, but I didn't switch. Because I didn't do any commit, it's still fine. Imagine I would have done the commit now. How do I fix this? Revert. Well, if I do revert, I create another commit, so even worse. This is one of the cases where I could do git reset half. Get rid of what I've done, just forget about it, and then put it again in the branch. So now I switch to the branch. So git switch authentication, git and out, git commit. System. Now, okay, how do I hear this word with upstream? Did we say what did we say?
With the pull request.
Did the pull request, yes, but before I can do the pull request, I need to put the stuff somewhere where people can look at it. Yes, so what do I do? Git push. Yes. What? No, first, so git push where? Already. What? Authentication. You said a name, but it's okay. What? No, it's new. I did it for clone. So, and look that GitHub, this is not Git, this is GitHub, tells me that I can create a pull request if I want. They notice that I've done something new, I pushed a new branch, so then they notice that this repo is actually forked, so they tell me, oh, you can create a pull request by following this link. Because we don't trust that GitHub always gets it right, we can just do it then manually. Also because if you use a GUI, you will miss that notification. So, I can look at the box here, it realizes that there is a new branch and it tells me that they could do compare and pull request. Let's imagine that we missed this box. Let's change to the branch authentication. And here, so basically if you miss that box, every time you go to a branch where there are commits on top of main, it will give you this box. Let's create a pull request. Actually, you should write proper things here, but we won't. create pull request. So now I'm finished, right? I create a pull request. Now I told upstream, hey, I have something new. And now upstream has to look at it and decide what to do with it. With telling me that the password is correct. And then we finish because we have 3 minutes. So now for example, GitHub. So look at the, now that we have the test pull requests here with a new one. This is me. Can you open it? And now here, if you look at the file changes here, you can now online look at what I have done, right? And you may like it or not like it. So can you So if you go back to the conversation, now it can tell me things. Yes. So we have already someone in the back. But basically, we can start a conversation here, and it can also. So this is, for example, a nicer way of reacting, right? So acknowledge the example. The example this one work for free. What is that? Some special thing. So,
I mean, this sounds not making it. I'm not doing it for show, but you have to keep in mind that online conversation is always lacking a lot of cues that we usually have, you know, like smiling at each other. So it does help to be seemingly overly friendly in these kinds of interactions. And in particular, if you're working with someone you don't know, it's different when you work with your teammates, but if you work in a larger group, try to stay up the.
So now I think it's lunch break if I remember to schedule correctly.
Yes.
It's lunch break, so then after the lunch break, I want you to fix this thing. So do the old for, close, create branch, fix the authentication so that we actually check that the password is correct and create a pull request. And then we continue to take it. It was so easy. Yes. Okay. Carlos, do we need any announcement for the lunch?
No, everything is ready. Can we just so the people just start for the introduction and inauguration. So just there are tables there. Just go ahead and sit down.
And how long is the break?
1.5 hours break.
So 1.5 hours. Then I expect you here 3:30, and we will start on 3:30. So. So thank you for being back. We forgot something important. I'm checking. So who am I? So I'm Guillermo.
Let's turn off the.
So I studied physics many years ago, and then moved to neuroscience. And then, because I like programming more than I like science, I started programming more and more, and then got a job in IT at the university. And then, so I'm happy to say that 10 years later, I don't do it anymore, so now I'm back to only teaching. So I'm teaching more or less what I'm teaching you, just and I work at the technical university.
Yeah. All right. I'm Jakob. Yeah, actually, so I studied physics. I was really into cosmology at the time. But then at some point I felt like this was really detached from everyone's reality. So it's like a good story of doing something around the bonfire. But it's not so good for actually having an impact. That's what I thought, but not that. That's the quality. But for me, I decided I wanted to do something a bit more applied. That's why I switched to computational neuroscience. Turns out it's also not very applied, but you need to do lots of programming. And because I studied physics, I don't know how it's going, but there was taking no education on software development. So we did some programming. The concept there was still we use C because I've been this alone. So I sort of learned the basics of C, which was very painful. But then during my PhD, I actually needed to do a lot of programming for setting up the simulations that we use to investigate neuroscience problem. That's when I joined the school as you in 2014, if I remember, in Slip. And then the following year, I became a local organizer, and then I had the organization. Yeah, and at the moment I'm working at the University of Bern in Switzerland, still computational neuroscience stuff. I look into models of
yes, and then maybe we get the chance, and so that everyone in the faculty can introduce themselves, so that in case during the week, I don't know, you have questions or you know who you're talking to. So could you please then one after the other introduce yourself?
Oh, should we go over? Yeah. Yeah. So you introduce me. Oh, I have to start now. Okay. Hi, I'm Lisa. I just finished my PhD in cognitive science. When? Last week. When I was still like a high school student and mostly doing just silly things for fun. And it turns out that amongst people who are doing kind of psychology, there's not so many people who know how to program. So I immediately got here as a research assistant. And kind of just kept going from there. And then I was a student at this school in Italy a few years ago. I don't even know, 4 or 5 years ago. And I've been on the team ever since.
Well, I'm Carlos, and I studied maths, pure theoretical maths, no background in programming, same as you. When I finished, I knew how to make a lot of demonstrations, but I didn't know how to use anything. So I decided to join a master course on artificial intelligence back in 2009. So no intelligence and none of our Tiziano as well. And but well, after that PhD in Austria, and then I moved back to Spain. Already in Austria, I tried to join the school, but so at the 4th attempt, I managed to get a spot in 2020, cancelled because of this. But the guys were nice and they kept the spot for the next year. So I was a student in 2021 Moldova. I loved it, so I wanted to organize, and I organized the 4-week edition last year in Bilbao. With the daughter, Alexander here, she couldn't hear, but I couldn't. And this year became so I'm the newest.
Hey, I'm Guillermo. Originally I come from Chile. My background is medicine, so I started to do medicine and then neuroscience. And then went to vocational neuroscience. I did my PhD in Berlin. And during my PhD, I found out about the school. So in the same year as you, we split, we were together as students. That was in the middle of my PhD. When I went to the school, and that helped me a lot, I have to say, a lot in the programming. I was already programming in Python, but not very good practice. And well, I finished my PhD in 2017, and I stay in Berlin. So I have a postdoc later, and now I have a permanent position in Berlin. I do visual perception research, so that's a mixture of kind of experimental psychology, computational neuroscience, and mathematical modeling. And then I just program every day. And I joined the faculty last year. So for many years I was not comfortable with the faculty, although I was a student last year, and this is my second time. It's really
cool. My name is Jenny, and I have a background in engineering. So started off as general engineering, kind of specializing in control and dynamics. I have since moved into more of the mechanical side, and my specialization now is wind turbines and wind energy. And I work at the Technical University of Denmark. I have been there for 7 years now, almost. I'm an associate professor there in the wind energy department. And my history with programming, technically Python was my first language. That's what they taught in our introduction to computer science in 2000, whatever year, I don't know. And then, of course, the engineering faculty used MATLAB, so immediately switched over to MATLAB and essentially was a MATLAB scripter for 4 or 5 years. And then during my PhD, I made the choice to switch to Python because I thought if I write all this code and then lose my MATLAB license, that's going to be a pain in the ass. So I switched to Python and was very self-taught. And going back on my PhD code is pretty embarrassing. There's a lot of random semicolons that don't need to be there. Yeah. I actually was a student for this school in 2017 in Greece. Liked it so much, asked if I could help in some way, and then I was like, well, you should teach. Like, that sounds scary, let's do it. So then I've been part of the school since then. and I've partaken in one of the schools in Australia as well. And then I'm teaching at DTU. I teach a master's course in loads, aerodynamics and control of wind turbines, which is a pretty hefty third semester course for our master's students. And recently I also teach a 5 ECTS course in scientific Python programming, which is meant for our master's and PhD students to kind of get them up and running. Kind of similar to this course, but slightly different focus, and we'll probably say not the advanced side of it, because a lot of our students coming in have basically no programming. Yes, and the last thing I should mention, that I almost forgot, sorry. I'm one of the points of contact for any sorts of issues in the school. Of course, Carlos is the other one, who you know about, I hope. So this is, if anything happens, if you were uncomfortable or didn't like something, or any sort of issue, it's not, but you just want to tell us about it, I would really appreciate you come talk to Carlos and me. So at least we know that there was something, and maybe we can improve or not, or yeah. So just feel free to come out and talk to us, and yeah.
Just to add to it, so this is not just issues about the school itself or the material. We're talking about issues in general. So do you have any problems?
Mutual partners things.
Yeah. If you're with Tiziano, you know, but you think that we legitimately, I mean, do feel free to talk. Yeah, oh yeah.
Which you can get it with CV alone. Kind of, the default is just not
all right, I'm Tita, and I am right now a postdoc at the University of Chicago. I work mostly on understanding the fundamentals of how we form memories. So it always involves collecting a lot of data, trying to make sense of that data. So I use Python extremely a lot on a day-to-day basis, and also like trying to visualize the data and present it to my peers so they can understand what I'm trying to understand as well. So I came, I came to the school in 2014, I think, and that was when I was just about beginning my PhD and transitioning from MATLAB to Python for a lot of the same reasons that did. And I'm very grateful to the school, because I think without it, I really would have been spending a lot of time doing coding, which is the philosophy of the school. And seriously, especially like the testing lecture, I think changed my life. Like without, you'd notice that too when we go through that. But in general, like also like just the advanced NumPy topics, like how you can use Python in a very efficient, streamlined manner. But in a very simplistic way, like it's not like mind-blowing programming, but it's you know, just like basic things that could help you speed up your code and not spend too much time like writing the same thing again and again and again in different ways. So yeah, and much better than using Stack Overflow all the time, which is and all of us start. You can continue. But yeah, so I mean, yeah, long story short, I've been trying to pay forward as much as I can, and I'm really happy that Carlos started this school, because it's much closer to me than flying to Europe. So, yeah.
So I'm right. I am one of these persons with a background in physics. For me, it was before that I was writing some code, but actually I was not spending so much time on writing the code, but writing the scripts to compile the code and to get it running on some other places. And so nowadays I have a key position with the theoretical community and within so I'm not doing the science myself anymore, but yeah, I've been around somehow since the beginning. So my relation story is that Tiziano and they needed someone to make it.
I'm Diego. Yes, my background is mathematics. And then I switched to neuroscience. And then I spent a couple of years in research. Then I decided that I had enough. Now I work for company in Switzerland as a data scientist. And programming more generation with Java. And then Frank into China, which is Python that runs in Java as a way to script Java. And I liked it, and then I switched to it was Python 1.7. And I did my PhD with Tiziano, so we started writing libraries in Python. And then
No, more.
Yeah, more.
Yeah, we're missing one.
So now finally you can go to work. Short recap, we have seen this open source collaboration model, reporting, cloning, and pull request. Now, our code now is still missing an important part. So we are the authentication part is missing. So we are not checking that when the user types in the password is correct. So what I want you to do here is that by using that workflow, I want to have from you pull requests that add this functionality. Okay. So, short recap, you need to fork the repo, you need to clone it on your laptop, create a branch with the proper name, work on that branch, one commit, several commits, whatever, to implement what we need to be implemented, and then create a pull request against upstream. And I'm going to look when we have a pull request, we can stop, have a look at the pull request, and then so that you experience that, and then we can improve. Again, use the stickers if you need them. We are going to go around, Jacob and me, maybe even some other faculty. Before you repo from the lecture, from the schedule, you click on the link, and that repo is the one that contains. It is reloaded page. You don't have to.
You raise it and I do it.
I am not able to
Yes, okay. That's why. Always.
Bueno, los gringos tienen que seguir siendo argentinos.
So, not everyone is ready, I know. So not everyone is ready, but because we already are over time, we're going to break at 5. We have 20 minutes, but there are another couple of important things I want to tell you about this. So even if you are not finished, I hope most of you have an idea of what you have to do. Now that you have done it, I've seen a couple of things that we can talk about. So follow me and stop doing this. We have already like 6, 7 pull requests, so many players managed. So a couple of important things. It is important to work on a branch. Yes. Many of you had the mistake of working on main, right? And then you push it to main, and then why is a problem? We will see it immediately. So the one thing that you probably didn't notice is that I forgot to merge the branch when I added the git node. So when you were doing git status now, you would have noticed that the data verification was present. as an untracked file, and I explicitly added the git ignore file to avoid this. But this was not available in my main branch, the one you closed, right? The one. So this is a good, and I asked the group to create a pull request where they add this git ignore file. Right? So let's look at how this works. First, I'll move here to main branch. Then let's first check we're talking about the right thing. This is my fork. Yes, so there's nothing here. The out file is not there. And the git ignore file is not there, right? So you see there's no git ignore file here. Now I look at the pull request, and in this pull request they added a file which is called git ignore. You see it here, with database and another thing. If I like it, I may want to now merge these pull requests. So here, I like them, and this thing I can do because I am the owner of the. So I'm upstream. I'm like NumPy now, okay? A NumPy developer. I confirm, and now then this is merged. I go back to the code, and now you will see that there's a git ignore file here. Yeah, it's new. It's here. How do I get it on my land? So if I say git pull origin name, you see that nothing happens. Already up to date. Why? So if I say git remote, look at what the remote. So the remote is my fork. It's not upstream. So if I want to get locally the new commits that have been pushed in the upstream grid, I need to connect the upstream variable with my variable on the left. This is a situation where we add a new remote. So we say git remote and upstream. Oh, sorry, upstream, and then I have to copy the URL. Here, the SSH URL. Switch to the terminal, add it. So now I have two remotes. I have origin and I have upstream. And now what do I do if I want to have the changes that are pushed to the main branch upstream on my network? We have done it many times. It's just that we called it origin before, and now I call it upstream. So what do I do? No, well, merge is part of it. Pull. So I say git pull, and now you see why it is important to always specify explicitly. So now where do I want to pull from? From upstream instead of origin. So I pull from upstream, and what do I pull? The branch main. And you see that now I have two files. I have one out file and I have a git ignore. Why is there out already here? Because this is so now I have the git ignore there. Everything is fine. So now I have updated my local main branch with the commits that are available on upstream. My origin is still not updated, right? So if I now go on GitHub and I look at my fork, which I think is here, here, and I will have to go the hard way. This, so I go to my fork on GitHub. And you see that here, this file are missing. Right? So how do I get that up to date? Push. Yeah, push what? Tell me more. So what do I do? Push from main to main. Yeah, but not from. You could push to. Push to origin from main. From main. No, well, not that. Main to. Yes, that's good. Not that to remote. So I'm pushing, and now if I reload that page, the files are complete. Okay? So now you understand what you should understand. It was important to work with the branch. Well, because now your pull requests have all been done without this commit where I had a git. So if I now would try to just merge your main branch with this main branch, I would have the same problem we had with Jacob at the beginning. Because there are new commits here, new commits there, and they are not connected to each other, so you cannot just merge like this. That's why it's important that you have a different branch. Because with a different branch, you can work on the branch and then merge the branches easily. You're not going to have any conflicts there. Is that less clear? So the rule is, even if you are the owner of the rig, you never work on main directly. You always work in a branch and you merge the branches. If you work with this system where you create pull requests, you never merge manually, you always just merge the pull request. Just like I did with identity node. So, Jacob was sending some comments to some of your pull requests. Do you have one that you liked that we can show as a possible solution? Which one? So who wants me to comment openly on their pull request? You? No, the one in the back, because you already in the they are the authors of the Git node. Which one is yours?
My username?
Yes.
RD Corona, RD Corona.
This one here. Yeah. So let's look at this a bit in detail. They have a title. The title I don't like. Typically, you don't use the past. You use it. So the sentence is like written like, if you merge this pull request, then you add authentication. So this is the sentence you have to mention when you write the title. So it's in present tense. This is what the thing does. Then they have one commit to this pull request. They want to commit to main, to my main, is right. I'm going to merge it to main. From his account, a special branch that he called authentify. Right. That's good. Then if I want to see what they have done, I can go here. And then let's see. And if they define an authenticate function, user takes user password. The password is available if the user is in the database. And if the password is correct, they print authentication successful. Good. Otherwise, they print authentication failed. And if the user is not available, they add the user. This is good. I like it. But there is a I'm not sure there is one thing that I'm not sure about, which is this thing here. Let me see, is it a problem? No, it's not a problem. But it seems like it. What is your problem?
Yeah, I mean, so some of you have already noticed this already when I was reviewing the pull request. It can get quite nifty. So yes, from a functionality perspective, this is very nice. I think it's doing what we want. But then you have to imagine you're a maintainer of thousands of people. So stuff like there's a type.
Yeah.
Right. Then there's missing space. So formatting. Like all of these things, people will comment on the pull request, and this will seem like they're just being a pain in the ass. But on the larger scale, you have to imagine that some of these kind of small mistakes they accumulate, and especially in large code bases. So you need to be very careful that you actually take care that the code that you merge into the main branch is in the clean state possible.
And look what I'm doing. I'm now commenting on this, right? So I can write comments so that then if we don't talk directly, they can look at what my comments are and please.
So don't take this kind of stuff personal. It's sort of feed on a bigger scale because there's this broken window theory I'm not sure how many of you have heard of this. But, so the idea is that, so when there's let's say there's a house on the street, and it's in perfect shape, but for many, many years. But then, one night, there's randomly someone drops a stone. So there's a tiny crack in the window. And what people have observed that once this tiny crack is there, the whole neighborhood deteriorates. So it's this idea of once it's deviating from this perfect ideal, then all of a sudden, all of these small changes then accelerate and ruin everything. So this is why people can be very nitpicky, but you should really keep in mind, sorry, that this is for the greater.
Okay, anyway, so this would be, now they could now fix what this thing and commit on top of this. So you can now switch to that branch. Can we do it now?
Yeah, I'm fixing the type on the.
Yeah, you fix it now, create a new commit, push it so that we see what happens here. Okay. And by the way, in the meantime, it does it. This broken window thing was used by Rudolf Giuliani, a right-wing major of New York, and has been disproved by social research many, many times.
It's not I have to remember.
I just wanted to point it out. Why they go home and really think about that. So, no, it has been disproved many times.
Just an analogy for
No, that's what we are doing now. So he is fixing on this laptop.
No, but I mean, if you made the changes in the page, and we have these commit suggestions button.
Yes.
It fixes automatically.
Well, who fixes what do you mean it fixes automatically? I don't know what you mean.
You give some suggestions.
Yes.
So you give like the right way to do it.
Yes.
If I commit the suggestion, it changes automatically.
No, it doesn't. So this is what he is doing. So he is now implementing my suggestions. He will create a commit locally first. He will push this commit to his branch. And then if I reload here, I will see the new commits added. Okay, so it's not automatic. He has to do something. He has to use the same branch, otherwise they are not connected. So you keep on working on the same branch. I hope this is done fast. Is it done?
Right on the comment.
Press the review. So, did you see any other errors that I have mentioned? Yes, the HTTPS. No, I just said about the So, come back. There are another couple of things that I see when I was going around that I wanted to notice. One thing that it happened often was that you did a form, then you clone using the HTTPS address of the repo. And then when you try to push, then it looked like GitHub wouldn't recognize your key and would keep on asking for a passphrase and a username and password and it wouldn't work. The reason is that you were using the HTTPS address. When you do the clone, you have to use the SSH address, which is the one that is connected to your USB stick. So when you push, you always have to have the USB stick plugged in.
I have to make the pull request again, or just by updating the
right? Push the branch.
I push.
So now I should be able to see the new commits.
Okay.
So you see, look here. GitHub tells me that there are new changes since I last viewed, and there is a new commit here with another typo in the title. So he fixed the typo, he fixed the comma. So we may say, yes, I like it. And I could now just go back and merge. There's not much. So I could merge the pull request. I'm not doing it now because I don't want to mess up the repo, but that will be. So the URL thing, is it clear? If you have done it already. So git remote -v. Let me make this a bit. So you see that these addresses start with git net. If you did the HTTPS thing, it wouldn't say HTTPS column GitHub.com and so on and so forth. If that is the situation, we have done it once already. How do you change the URL for remote? If we go set URL, origin, and then the address, right? So whatever the address is, in this case, I can just change it to the right one. I can just not change it, but so that you see that it works. Right? And then this is changed, and then the authentication should work. So another thing that I've seen people doing is that they forgot to create a branch. So they did their commits on main. How do we fix that situation? So let me now just, for the purpose of showing this case, let me just create now a commit on the main branch. Yes. And git status. Oh, I'm in the wrong break. Sorry. So here we add a line. Here, git status, you see it's modified. Add git. So now I notice, now too late, that I'm working on main. And this commit actually should belong to, I should put it in a different branch. So how do you go about it? What could we do to fix it? If I do revert, I create an additional commit on top of this, which changes, adds another commit on main. So I even do even worse. I have one commit and then now we will have two. So no, revert is not the right thing here. So first of all, right, before we create a branch now, it's never too late to create a branch. So we call it git branch command. And now if I switch to this branch now is identical with my local main, so there is this commit here. Now I go back to main. And now, how do I remove commits? We have done it already. Git reset, and then to what? To the SHA of the commit before the deadline, right? And if I'm lazy, I can also do this. So one commit before. So now I'm back to the one where I merged your pull request with the git remote, the commit is gone. Now you should be scared because we have just got rid of that commit of the changes we have done. Like if I open the file now here, the line is not there anymore. But because we created a branch, to the comment branch, we open the file and magically the line is back. Right? So the commit is not lost. So if it happens, you have to do the things in the right order. Of course, if you do git reset or creating the branch, the commit is lost. You create a branch so that your work is safe, and then you can reset. And I suggest in general, when you start using this stuff more frequently, that is always a good idea before you do git reset something to create a branch so that you know that you have somewhere a branch where the work is stored, even if you think you will not need it anymore. Create a branch so that the stuff is safe, and then do your work. Another thing that is worth saying before sending you to a coffee break is that when I do stuff like this, changing the history, I can only do it if I haven't pushed the commits onto a remote. Because if the commits are already available in the remote, and if I change the history locally, then the history is not compatible with the one remote, and then I will not be able to push it. playing around with reset, you can only do it before you have done push. Once you have done push, the damage is done. Then the benefit is to do the reverse. Then you explicitly create a commit that gets rid of the wrong things, and you push that. It will happen that you will do it during the school, and then I will teach you how you can still push, but I don't want to show it here. This is what I call Git pornography. You only do it when no one does it. So I'm not sure if you know. Coffee break. Yes. 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 Just the problem. The problem that you say. Yeah, please.
Okay, so for those who are still here, now in the next lecture, as we mentioned before, please change for
Yes.
Do the switch button.
Yes.
So position in the room. So if you're in the back, try and sit in the front. If there's a front, back.
Oh yeah, that's new and I like it.
But go to the coffee break now.
Yeah.
Yeah, go. You need the coffee break now. So you
Was like, if, for example, if one thing is missing, I'm more likely to like make more things. So, oh yes, I can use it. Yeah, but a lot of people use it for whatever combination. This is just saying, even if it's messy. But we don't really have the words separate from the original indication of. Well, and also in the sense of like, I know for myself that like getting questions around the capture, I'm more likely to do that. Yeah, exactly.
You didn't even understand. No, but I think you like. No, make explicit about nothing.
Working keyboard cannot make it complete.
Oh, yeah.
No, coffee break. It's in the white wash. I love this one. Tengo a lot, ¿no? Por ejemplo, que de lunch, no, it's not fun. I mean, I put it in the and then at some point it starts. So that's like
We don't really need that part. Right.
the thing with this, and then I should share my screen, right?
Yes.
Okay. Like many of these.
Ahorita vamos a realizar una nueva uso.
Now? Oops.
Yeah.
Okay, and now I should share the screen.
Yes,
this one.
I have no idea.
Kind of here. Yes. Sí.
No. Voy a poner aquí para que se pueda cambiar. Sí, cambiar. Mi idea aquí se van a cambiar los equipos. Ok.
Ya vamos a cambiar de profesor.
Sí. Y de partners también.
¿Ah, sí?
Puedes cambiar de equipo. No, no, sí. Me quedé en el centro. Sí. Sí, está sí, se cambia de parte.
Si quieres
Which partners? Which partners? Right. Ahorita empezamos a ver.
partners, and all right. Welcome. Yes. Welcome to something a bit different, different release station. So far you've done today a lot of GitHub. Now in the last 2.5 hours, we do something a bit more visual. We talk about data visualization. We have it divided into 2 parts. So Carlos is going to give you some principles at the beginning, and we're going to do also hands-on exercises. That comes in a moment, and that's where this cheat sheet comes into play. Okay. So for the first thing, first I wanted to say one thing. Thank you, they're not here, but this material, our material is completed from previous material from my file in Nicolas. You're not here, I would like to send them. Yes, because we cannot take over their material from previous days. You had a question?
I just need another section sheet.
That's the plan. So we do practices first, which is a little bit of talk, maybe 20 minutes. Then we do a hands-on exercise. If you do the notebook, you will see in a moment. Then we come back and I talk to you a little bit about common errors in visualizations and which kind of data visualization there are. And then we do a second exercise. In the second exercise, you are going to also rehearse the forking, branching, pull requesting. So that's in the second. Right? Okay, so that's it. Well, first definition of visualization scientific computing. We will read it and there are some words emphasized. Visualization is a method of computing to focus symbolic into geometry, enabling researchers to observe the simulation and computations. Visualization offers a method for seeing the unseen. It enriches, most important, the process of scientific discovery and processes profound. Now it seems to be like words, but we'll understand better later. Okay, first classical example. You can see there 4 data sets into variable seeds, Y. Okay. You believe it or not, you can just make the numbers if you want, but both means and variances are the same in X and Y in all 4 data sets. Also, the correlation coefficient, the linear regression line, and the coefficient of perturbation is the same. Okay. So, are they identical? Yeah, I mean, my favorite answer to my question is it depends, right? Always it depends. That's the best answer always. It depends, because if you're using any model or whatever that takes into account all these numbers, they are completely identical. But then, in order to understand that they are not, it's very little we just plot them. Okay? They are completely different. Also, we have there the explanation of what they mean. Okay? There's a regular data set, a nonlinear data set, and then one outlier in the x-axis, one outlier in the y-axis. Okay. Good. Now we have another example. This comes from a package in R called data stores. And we also have the same. All of those numbers are common to all these data types. Okay. Good. Happy breakfast. Happy breakfast. Good. Now, Okay, this is what it is, right? The thing is that just number and statistic is not the whole story. Okay? We are humans trying to show our stuff to other humans. So that human perspective, those human aspects have to be taken care of. Okay? And as soon as we understand how that works, we will be able to present our stuff in a way. Okay? We're not trying to give you a Bible about how to do that, but it's having sense to Well, start. Okay. What is our main challenge? We want to map from data, data information to something visual. Okay. What's the thing? We have different types of data. We have quantitative data, we have qualitative data in the form of categorical variables. You could have categorical variables that have an order, categorical variables that have no order. Examples, for instance, a categorical variable that have order is this dog, cat, fish that's in the middle, for instance. One that is ordered is this good, fair, poor. Depending on the type of variable you have, you can use this type of elements or tools. If you have a numerical variable, it's normal regular to use this XY axis, and it's okay. But it's for sure not okay with this dog, cat, fish variable. Even with this dog, cat, fish variable, it doesn't make sense to use shape or sizes because there's not an order. So why being first of either a dog or a cat or a fish? Okay. Well, fish is mathematics do this. Okay. So for this, for example, for this variable, dog, cat, fish, the right thing to do would be to use some type of color palette to distinguish them all different line types. But for instance, not different languages because of this type of color. Okay. Good. There are many rules we could think of, and it's not our aim here to give you a complete list of rules. We're going to see some insights and some advices or some important things that we can take into account. This is a aim of this. There is a paper, open access, from Nicolas, Guillermo, some other locals, telling us about 10 simple rules. We'll see these 10 rules, and we'll talk a little bit about them, and this is the first part. First, you have to know your audience, right? If I'm talking to my colleagues, I can be really complex in my messages, in my visualizations. If I'm talking to the scientific community, I can expect different backgrounds, so I have to be a little bit more relaxed in terms of complexity. If my students are looking at me like casual and trained, I realize that I have to also lower down the complexity of my messages. And in the general public, more. All right. Here I have an example. This is my general audience. This is about cancer, information about cancer. And we have a separation between groups, women and men. And it's really interesting because this could be also for general audience on program. You can see interesting things like these new cases together with deaths. This is possible because there's some of the cases only, so they are always smaller, and they are really informative. You can see here, for instance, that the new cases of lung cancer in women are less than in men, but also the proportion of deaths is higher in women than men. You can see here that you have a liver cancer, you have a real zero curve. Okay. The thing is, once you know your audience, once you know the message you want to send, once you adapt the complexity to mean, you just find the right visualization for it. And I think this is a good example. You have to identify your message. This is the second one. You understand this? Neuroscientists around? You understand this? I don't. Okay? So, for an audience like me, this is not a good message, okay? But the thing is, as soon as you can really put there all the information you want to give, it has to be understandable at first sight, just reading a little bit of stuff. Okay? So the message has to be clear and fast understandable. The thing is that usually past years there were a lot of neuroscientists. So they all understand everything, right? I was like the nerd one that didn't understand it. Okay? So that's the problem. You have the audience identified, the message. That means that there is certain type of transformation to go from one brainstem structure to the other. Okay? And the good thing of this is that someone that understands really the matter will just see it and okay. You have to adapt the figure to support the meeting. What does it mean? You cannot use, or you should not use the same type of visualization for a paper, for instance, in which the reader can be long time just having a look at the details and take a really good look in depth at what it needs. For instance, here, you have here these initial conditions you read, and you have also transparency in the colors that is related with the density of the lines. Okay? But for a talk, this is not useful because in a talk you have really short time. You have to be, you need the people to be focused on what you want to talk about. So something like this, only short amount of lines, important points really visible, so I can just refer to them fast. Captions. Captions are not an option. Okay, I would never say this is a caption. It's almost nothing. Okay? Because what is this? It says optical illusion, but which is the illusion? Right? We have a right caption. It says that A and B here, both patches, has the same color, but as an optical illusion, I don't see it to be the same color. See different colors. Okay? So this caption helps me understand the image, and it's right in this caption. Defaults. The defaults are good for any picture, for any visualization, but are not perfect for any of them. Okay. These are originally the same data. This will be much better, right? In fact, in the exercise one today, we're going to transform stuff from default to fancy. Okay. This is the okay. The use of color is really important, but Guillermo will talk a lot about that afterwards. So let's jump this. We should try not to mislead the reader. We are dealing with data, and we are showing data, so we have to be really, really, really objective. As much objective as we can be. Okay. This is the same data. The thing is that here is the real data. And here is the same data, but we have the scale. And then in the new scale, it seems to be much, much more different than this. Okay. That's good. I mean, you have this and you want things and whatever maybe is good for you, but it's not objective and it's not fair. Same idea, okay? If we use here the area to show the differences, and there are short differences, if we decide to use the radius, the difference seems to be much, much bigger over here. Okay? This also What we have to do, as a rule of thumb, is try to use always the most simple one we can find in such a way that we are as objective as we can be. Okay? This is the aim. And also important thing, if you prepare any visualization, do not hesitate to ask any colleague. To ask them if they are able to interpret it right or not, because this is probably the best support you can do. Some examples that are really fun. This one. Right. This is 34, and this is 214. And those are real examples. Okay. This is great. We also have to avoid charter. Charter are unnecessarily confusing visual effects. Which is the problem here? We cannot distinguish lines. The lighting is overlapping the lines. Also, the colors are really poorly chosen. Some of them are hard to distinguish even here. There are so many ticks that they are overlapping. Also, this grid is not aligned with the sign up. Doesn't bring any inside. Okay. So in this case, this would be an option. So you can just have a look separately to each of the lines. Then you have much more. Use however you need. Use the colors you need. Use as many labels as you need. Whatever you need, but always be aware of the. I mean, we have been all lazy plenty of time, and leave the default and leave whatever, and we all have done it. But it's up to tell you what to do. Something I really like. Message trans beauty. I really prefer this. I like it a lot. I mean, sometimes just a sketch is enough. I mean, it's the same information. But just a simple sketch would be enough to tell the others what you want to see. And I think that you see this, or you see this, and you go on with a different background message with this. I don't know. It's my favorite. There are plenty of tools you can use, so you should always try to get the right tool. Some examples here: PDF crop removes white borders, graphics can create easy graphs. Image Magic is meant for script image processing. GIMP for manipulating bitmap images. Inkscape, the same but for vector images. This is for scripted vector art, and there are many others.
All that open source.
Yeah. There are plenty of visualization libraries, really a lot. We're going to focus in macro-lib, and there are many libraries available in Python that use themselves macro-lib. Okay? But today we're going to focus in the macro-lib inside. Okay? Seaborn, we're going to see a little bit. I also have used Yellowbrick sometimes. Awesome. Starting up this first part, we go directly to the exercise.
So we go to the first exercise. What you have to do now, as you've done now already in the previous lecture, you fork the repository. So if you go to the schedule, you go to data best practices of data visualization. Right? This is our record from this lecture. You fork it. You clone your fork, right? And you go to the Jupyter Notebook exercise 1. So from the console, so in your laptops, laptops, you are here, you will do in your laptops, you will do Jupyter notebook, and then you will launch the Jupyter notebook interface, and then you just navigate to notebook to exercise 1. So, and this notebook, as you see it here, is self-paced, so it has different exercises, and you code, you start to fill out the code and be running the code. Everybody used Jupyter notebook before? Who hasn't? You are two together, that's not good. So you have used Jupyter notebook. You're two together. Maybe if there was a support there, so everybody has used Jupyter notebook before, right? So you go about one by one in the exercises. You don't need to commit yet. You don't need to add the changes. It's just for you. And the idea of the exercise, just to give you the idea of the exercise, is you start here. You start with this visualization, and you end up with this type of visualization. So you start with the defaults, and you start tweaking the defaults one by one until you get something much better. That's the idea. Okay? We will be around answering questions. And for that, use your cheat sheets, of course. Esa ya es completamente diferente. Sí, acorde a y podemos los valores. Entonces es cierto que
Y al final es
So if I hope, so who has already been here? This is Sanchez. Okay. The idea is that, so we have 10 more minutes that you are right there, the ones that you have. Here, this was section 1.2. There was a typo. If you have already been there, then just continue. But at least we arrived at this. Yes. For 10 more minutes.
Ya no había nada.
All right. So, come back. Did you manage to arrive to strategy, everybody? This part? Yes? Okay. So, why I'm saying this? Because I want you to arrive to them. Because you realize that when you only change strategy, the complete aesthetic of the block changes. And that already improves a lot very fast. So, just want to re-emphasize this, is that you have many already default options that you can play with. And here you can see them. And that's kind of a good base start. And then you have to, you want to maybe in your block tweak the different things. And for that, you have all the different options of things and labels and slides and all that. If you didn't finish now, it's fine. Afterwards, you will have this for yourself. You can continue working on line styles. You can change the tick positions and labels of the positions. The spines, which you don't know before, the spines are these lines.
You can change the spine. There is a thing that is called the set order, so where the things are in a layer. So you can change the set order. So, that's it. So you can put things in front or behind, depending on what you want. You can change the legend, add legend, change the font size, and save. And then the last thing that this notebook does, that you probably know already, is subplots. So how to make different panels. You'll probably use this. Now, an interesting thing is that you can also do, the panels don't have to be necessarily the same size. You can also do this kind of things. And that's kind of interesting if you want to emphasize one of the plots against the other. So the idea also, I mean, of this exercise first is that you get a little bit of hands-on on how to tweak Matplotlib. There's many other things. Second is that you try to, when you do a visualization for your paper, for your talk, or whatever, try to tweak as much as possible in Matplotlib, so that the final figure is almost the same as the final one for your publication or for your talk or whatever. Because that also makes the analysis reproducible, right? We have been talking about before. So you continue with that. I mean, you can continue with that later. So now we're gonna jump to a little bit of another topic, but that's the idea of this notebook. This notebook is tweaking notebook. Okay. So what we also wanted to tell you, what I wanted to tell you too, is maybe two tools that you don't know or maybe not know. One is so because the question is how do you choose an event? You always have in your field you will have standards. Sometimes this kind of data is plotted with a scatter plot, this other is with a bar plot, and so on. But sometimes if you're lost and you don't know what you want to be creating, you can also get inspired by, for example, this catalog that is shown here. And I show you here that are, so you can search by function in this data visualization catalog. And the first thing that you can choose, for example, is what are the things that you want to show? You want to show comparisons, you click them, and then it presents you a wide variety of different kinds of visualization. Which sometimes is useful for, as I said, to get inspired. For example, there is a Whisker plot population experiment. And here, when you go to one of these, it tells you a description of what it does, what this plot is good for. And for some of the examples, it has also Python code, so you can get inspired by that too. How to do it with Matplotlib. Not for all of them. So I use this tool sometimes. I mean, I use this tool sometimes when I don't, when I'm not sure how I can visualize the data in another way. So that's one thing. So if you're lost, you can do that. There's also another tool that is a bit older, so it's not online, but it's called Chart Suggestions by Abela. Abela was a data visualization guy, which is basically also another workflow. So in the center it says, what would you like to show? If you do relationships, if you want to do relationships, then you have these options: minimum, comparisons, distribution, composition. So, and depending on, so you can follow the tree and say you want a comparison over time, few periods, many categories that maybe it's a line chart. This is of course not a full comprehensive classification, it's just a start. So you can use it also to organize yourself and to say, which kind of visualization you want to use. So this is, all the slides are in the GitHub, so you of course have access to this. So that's the tools that I wanted to show you. And the other thing that we wanted to show you a little bit more detail. What Carlos was saying before with color, so use with color. I want to go into the detail a bit more because I see a lot of mistakes done with color. And I'm a vision scientist, so I get not annoying, but I find funny the kind of mistakes that people. So the thing is with color, if you use color in visualization, which is almost all of visualization have color. You have to know that color is a three-dimensional perception space, so it's 3 dimensions. And you maybe have heard these terms, hue, saturation, and brightness. Hue means is the color wave, the rainbow or the color wave. And this is a circle. So it goes from yellow to red, blue, and so on. Then you have saturation, which is how much of that color you have. So how much of red, or how much of saturated. And the other, like is a red, is how bright. Is it dark or is it bright? So if you have data that is increasing, so it's sequential, can you use hue? Do you think you can use hue? No. So to code data, a data set or a label that is increasing, you cannot use hue. So you can have to use either saturation or brightness, because our perception of hue is circular. To code something circular, that is fine. To code angle, for example, or to code months in a year, something that is circular. And matplotlib, and you can use this is a screenshot of also here from the cheat sheet. So, you see that there is color maps in matplotlib. And this is not no coincidence that is there, and there's a lot of color maps. Because depending on your data, you should use the correct color map. So if you have qualitative categorical data, so for example, dog, fish, cat, these 3 things don't have order. So the correct color map would be something that is qualitative. So in this coding of matplotlib is tab 10 or tab 20. These different colors don't have an order. They don't relate to each other. So that's how you map categorical variables. On the other hand, if you have something sequential, for example, year, time, or something that increases size, all that you have to use a sequential format. That's the correct thing. And here there's many. You see here there's uniform color maps, sequential color maps is the second type, and then you have a lot of options. Here is just an example. Then the next one is diverging, and that means diverging is you use it when there's a natural zero. So, for example, temperature, you have plus and minus, where you have increase of 0%, increase and decrease. When there is a natural zero, the zero will be mapped to white, and then the increase to red, and then decrease to blue. So that is called a diverging color map. And matplotlib also has them in there. You can choose many of those. The classical will be red and blue, but there's others too. And the last one is a circular. So a circular color map, as I said, it could be the rainbow. But there's also others. And this will be useful for orientation or direction. Something is in an act. So many of the color maps that are here in matplotlib come from this tool, which is called Color Brewer, which actually comes from the cartography. From cartography, people that do maps. People that do maps know a lot about this. And I know about which colors you should use for the maps. So if you go to Color Brewer 2.org, you see actually a tool, an HTML tool, where you can click. You can click on. So here, you can click on how many colors you want and which type of data. So here you need to know if it's sequential, diverging, or qualitative. So for example, if I choose diverging, and then I choose this one, and here it probably shows me it shows me the X codes for the colors. The matplotlib, many of the palettes that are in matplotlib are based on this color brewer. But if you need something extra, you can also go directly to the tool, which this actually was a list. And the other thing is that Color Brewer has, which is nice, it has this option here, which says color blind friendly, or color blind safe, which is also another issue in using color for visualization. Because some people cannot distinguish red from green, and it's not very tricky. It's estimated at 10% of men. So let me go back. So that's color blue. Exactly. So consider color blindness, because this is an example of the red-green for a trichromat, for a normal vision person, and this will be what a person will see if they don't have red-green. They have red-green color blind. So if you use red and green, for example, for there's three types of color blindness. These three names, but you see that for them they look very similar here and here. So actually, color bluer also has an option of colorblind save, so that you can pick color palette, colorblind. So, for example, this one. So this one was not. This screen cannot be discriminated by these two types of color blindness. The others, for example, if you would choose this pink, red, green one, then this will be perceived as different by the colorblind person, but they will still be discriminable. So this is an example, for example, color blue, it's called pink, yellow. So think about this too when you do this color. All right. So and other common pitfall with color is including too much information. So usually you shouldn't do this because there's way too many tones, and then you cannot actually distinguish. So coding too many colors. And the other common pitfall is using the wrong color scale. So I just explained to you what would be correct use. Using the rainbow scale for something that is a heat map or something that is plus minus is not correct. And I see this a lot in publication. In MATLAB is correct. Rainbow color is not a sequential color map. So our perception is not linear perception. So
yes, I don't get why it's not correct to use rainbow scale. I mean, it has when you have sequential data.
Yes,
you have two different ends. You have red and you have
yes.
green.
Yes, because our perception of the rainbow or the hue is not sequential but circular. And you will see in a moment. So maybe I'll show you this in a demonstration. So this one. So we start with a picture that is full color, the Mona Lisa. We convert it to gray scale, only gray scale. So these are these values of intensity, of gray value between black and white. Now we map this with the jet or rainbow, color map, and you see this. And you see that our perception of the gray scale of the picture is completely gone. Some things are highlighted, and some differences are inhibited. It's not perception is not the same. This will be the jet. Now in MATLAB, there is one of the color palettes that is sequential is called Viridis, which is the default now. If you now will map this same image, and I will map it with Viridis, you see that the output is much more similar to the gray scale. Do you understand? Yes. So, all right. So, any other question? Because that was about color.
Yeah. Just a conclusion of this is if you use any sequential schema, you will have a similar resolution.
Exactly. Yeah. So you could try this and change this Viridis for any other sequential map, and the Mona Lisa will still look similar to the original. But if you use something that is not sequential, then you will look something will be completely different. So when Carlo was saying you're mapping data to color, if you do that, you have to be sure that what you're mapping is linear. So, all right. So that's with color. The second exercise that we go to do now. So this is the second notebook in the next half an hour. So the idea is that you have it also already in your cloud, in your fork. Go to exercise 2. This is completely different. So it's not completely different, but it's a different setup. So The idea is now that you open this notebook. There is some data in it that you will see here that we load with pandas. This is just for loading the data. So there's data in a CSV file, and this data comes from a data set that is called the Human Development Index, which is done by the UN or by some official organization. And it has different countries, different years. They have the HDR, which is how developed the countries. And they have three things: expenditure in health, and education, and social protection. They have also the GDP per capita, in which region this country is, and whether this is global north or global south. So the idea of this is that here there are 5 different questions that you would like to answer. Yeah? And what your job is to choose a visualization, given the tool that I gave you, to try to answer that question, to try to do a visualization. And also to do it with your partner, of course, but only one of them. So only one of these 5. Okay? So you will do A, B, C, D, E, A, B, C, D, So we divided already. Each group knows which question to do. You develop in the notebook, and when you're ready, you commit the notebook and you do a pull request. And we will review your solutions here in front. So try to be try to make a publication ready. Yes, no. Yeah. So we will review your solutions, all of us. So
we should work only with the filter data.
Yeah. Whatever you want.
Because there is
yeah, but this is just an example. You can do whatever you do with the data. You can rearrange it or do whatever you want. So I'm going Igual, y aquí parte de este valor sería los países ya los países que te van a
¿Tres por dos o dos por tres? Yo creo que eso es claro. Y aquí ten more minutes. So, please, start the meeting. 10 more minutes. Somos los países. Cada país. No, cuando es que bueno, y ahora
Guys, one second. Does anybody when leaving doesn't have a car or how to get out of here? So you're by foot, that's what I mean. I have a car. So who's by foot? Okay, and who's by car? No, I don't think. They have 3 spaces. Okay, we should figure that out because it would be nice if the guys for the car would just drop the people at least at the metro station so that this, I mean, now it's dark and etc. etc. So yeah, okay, when everything is done, we'll figure that out.